samarang sliramu, mergo omongan dadi salah paham. Janjiku tak patenke ing jero raga iki, supaya tansah kelingan sliramu. Wedokan liyane ra bakal bisa ganteni jenengmu, tak ukir sajroning ati. Pengen ku siji nyanding sliramu tekan ati, tungaku ra bakal mandeg sedurung sliramu bali. Tak duwake ora
Lo, mangga, mangga. Oh, di rumah. Di rumah. Oh, di mana tuh? Di rumah Anda. Oh. Selamat ulang tahun. Panjang umur, panjang umur, panjang
kudu
umur.
jarak sing gawe awak
Ya, sehat-sehat terus. Kurangi merokok, kurangi merokok. Sama ngopi kurangi. Ya, sampai malam ya di situ. Hah? Olah, olah, libur. Ya, udah rumah aja belajar. Lihat bisa ah. Basa-basi itu payah. Nggak bisa sebonta tuh situ potong loh. Ajin potong rencananya nak sebonta loh. Ajin pun potong rencananya nak sebonta tapi tertahan di situ. Ya bisa lah Ajin. Ya bisa lah. Eh, ya bisa lah. Nah, oh iya, ya bisa lah. Ya lah ya lah. Lanjut lanjut. Dah. Assalamualaikum. Stop loh rambut nih. Asu asu.
Jira is now for all teams, even those cross-functional super teams that keep project managers up at night. With everyone cruising on the same page, tracking and reporting progress.
Some of the words people use on Kaggle can be pretty confusing, especially if you're new to the community. So I put together a Kaggle vocabulary guide to help you get started. Let's go. Propose a rule tool and that you might like to play around with. So we've had some cryptography, and I guess if your family is full of nerds, it could be like a fun, and by people I mean you, it points to, it'll be noted in the competition description. So more competitions lingo. In class is what people can use, and by people I mean you, anybody, to host their own Kaggle style competition. So a lot of people use them for courses, but I've also seen people using them for hackathons and meetups, and I guess if your family is full of nerds, it could be like a fun family reunion activity, I guess. I don't know, for any reason you can do a Kaggle competition within class. All competitions, whether they're in class or run by Kaggle, have a leaderboard. So we have an example over here. And a leaderboard shows the ranking for all the scores for the entries that have been made so far. And there are two leaderboards. So there's a public leaderboard, that's the one you see during the competition, and there's a private leaderboard. Generally, you only see this after the competition is ended, and generally it's scored on a different set of data. So if you have a model that's really, really good on the data on the public leaderboard, you might actually be overfitting, and then when the private leaderboard is revealed and prizes are awarded based on the private leaderboard, you might find that your rank has suddenly dropped. So the change in ranks between the public and private leaderboard is called the shakeup. So I mentioned usually people go down if they're overfitting. You can go up if you're following best practices, you're doing your cross-validation, you're using regularization, you're just really striving to avoid overfitting. You might also people talk about being in the money, and people at the rank that are
Cross-validation. Wih, buku aku. Aku pikir buku aku hilang. Rambut itu belajar. Cross-validation itu kayak apa? Pernah baca. Oh, aku pakai key fob kan. Eh, enggak. Ini aku pernah baca aja sih. Oh, okay.
Are in the money. So here it has a light green, the money. You might also people talk about being in the money, and people at the rank that are in the money. So here it has a light green background, and above, after the shakeup, will receive prize money if it's a competition that offers prize money. And then below that, so people who are in the money also get gold medals, and then below that we people who get just gold medals, just silver medals, and then bronze medals. Something else people talk about in competitions is leakage, and this is actually a general machine learning term, and the idea is that you have information about your target variable, and it's included in your training data, usually unintentionally. Information about your target variable, and it's included in your training data, usually unintentionally. So a classic example is you're trying to identify pictures of a specific type of flower, and all of the pictures of that specific type of flower were taken with one camera, and all of the other pictures were taken with a different camera. So you build a camera detector, which is very accurate on your test data, but then when you want to go and identify pictures of those flowers taken with different types of cameras, it's not actually a helpful model. Another example would be if you're trying to determine if somebody will get an illness. And you have information about whether or not they were treated for that illness. So treatment would occur after diagnoses, and you're trying to figure out what the diagnosis is. But if you have information from the future, then it's not actually going to be helpful for you later on when you're trying to apply that model. And we do a lot of work to really minimize competition leakage, but sometimes you'll hear people talking about it. So that's what they mean. Finally, the progression system. So Kaggle has a 5-tier progression system. Everybody starts as a novice. Everyone on Kaggle was a novice once. And then there's a checklist of things you can do, and once you finish that, you are a contributor. And the reason that you'd want to go through the checklist, things you can do, and as a novice, everyone on Kaggle was a novice once. And then there's a checklist of things you can do, and once you finish that, you are a contributor. And the reason that you'd want to go through the checklist is because once you're a contributor, your vote starts to count for awarding people medals. Medals are important for moving from the expert, master, and grandmaster tiers. So there are actually 3 different ways to become a grandmaster. You can do it through discussion posts. So a lot of people have upvoted a lot of your posts and they've gotten medals. Kernels. Again, a lot of people upvoting a lot of your kernels. So kernels, again, are your code that you've shared. And competitions. And for competitions, you need to get a certain number of medals for a certain number of competitions. And again, medals are calculated based on a number of things, but mainly the number of non-novice votes on... They're all based on votes, but the non-novice votes only count. And there's some other stuff we do to avoid... And there's some other stuff we do to avoid abuse. It is pretty tricky to become a Grandmaster. So we have more than 3 million Kaggler's right now. I took these counts in June of 2019. And we only have about 145 competitions Grandmasters, 11 Kernels Grandmasters, and then 12 discussion Grandmasters. So it's a pretty small elite group, but you can get there with hard work and dedication and by contributing to the community and producing useful content. I believe in you. All right, so that's all the Kaggle vocabulary that I wanted to introduce you to do today. And now that you know some of the words that people are using on Kaggle, I hope I can see you on the site, in the forums, or entering competitions, or writing some kernels. I love seeing people's kernels. So I will see you on Kaggle. Bye!
I just made a $27 ebook in 2 minutes using AI. Watch how I did it so you can do it too.
Wih, gimana?
Have you ever thought about joining a Kaggle competition but don't really know where to start? Well, you're in the right place. I'm Kaggle data scientist Rachel Tapman, and today I'm going to show you how to enter a competition. Joining a Kaggle competition but don't really know where to start? Well, you're in the right place. I'm Kaggle data scientist Rachel Tapman, and today I'm going to show you how to enter a competition. Let's see kernels that people have recently run. So looking through here, oh look, here's an example submission. Rachel, is that you? Yeah, that's me. I made this earlier. Do that on your own. So I've accepted the rules for this competition.
Where's my glasses? Where's my glasses? Where's my eyeglasses?
Probably going to want to read through the rules, but I actually read through them earlier, and you can do that on your own. So I've accepted the rules for this competition, and I've joined the competition. Let's find a kernel to work off of to enter a competition. All right, to start off with, we're going to pick a competition, and I already know I want to enter the housing prices advanced regression techniques. So before I join, I'm probably going to want to read through the rules, but I actually read through them earlier, and you can do that on your own. So I've accepted the rules for this competition, and I've joined the competition. Let's find a kernel to work off of. Let's see kernels that people have recently run. So looking through here, oh look, here's an example submission. Rachel, is that you? Yeah, that's me. I made this earlier. So I'm going to click on this example submission here, and this is going to walk me through all of the steps I need in order to enter a Kaggle competition. So rather than just reading through it here, I'm actually going to copy and edit this kernel so I have my own copy that I can work in. It's going to take just a second to spin up. When you enter a competition, there's a couple of basic steps you need to do. First, you need to train your model. I'm doing all of this when my rather than
ini maksudnya
just reading through it here, I'm actually going to order to enter a Kaggle competition. So rather than just reading through it here, I'm actually going to copy and edit this kernel so I have my own copy that I can work in. It's going to take just a second to spin up. When you enter a competition, there's a couple of basic steps you need to do. First, you need to train your model. I'm doing all of this in Kaggle kernels, which means that our code is going to be run on Kaggle rather than on my local computer. So this kernel already has a lot of the information we need in it. So we are reading in some helpful libraries. This is using R. You can also write a kernel in Python if you prefer. Loading in my data, and then I'm setting a seed for reproducibility. From here, I want to actually train my model. So it looks like this person, it's me, has already started training a very simple model. We're doing a test train split for cross-validation so that I can check that my model's not overfitting. And then there's a little bit of pre-processing. We're taking the training data. We're removing the column that that we are trying to predict sale price. And then here we are converting strings to factors, and then we are doing some label encoding. So this is just taking categorical factors like, I don't know, zoning and turning that into a number so that we can create a matrix. And from there, we can use our matrix as input to an XGBoost model. So let's train our model really quick. And if we look at the mean average error, which is what this competition is going to be graded on, I can see that it looks like it's actually still going down as we continue to do lots of boosting rounds. So this is an XGBoost model, and the number of rounds you train it for will affect how much complexity in the data you can model. And let's make sure that we're not overfitting by running the same model on some of our held out data, so doing some cross-validation. And it looks like the test error is actually smaller than the train error. So what I'm going to do is just increase the number of training rounds and see if that's still the case. All right. Yeah, and it looks like it is. So I think just by increasing the number of training rounds, I should get a better performance than this kernel originally had. So once we have trained our model, we can actually make our predictions. So our predictions here are going to be based on this test CSV. So our predictions here have trained our model. We can actually make our predictions. So our predictions here are going to be based on this test CSV, which if we look at our data set, we can see that the train CSV has 81 columns, and the test CSV has 80 columns. I should get a better performance than this kernel originally. Increase the number of training rounds and see if that's still the case. All right. Yeah, and it looks like it is. So I think just by increasing the number of training rounds, I should get a better performance than this kernel originally had. So once we have trained our model, we can actually make our predictions. So our predictions here are going to be based on this test CSV, which if we look at our data set, we can see that the train CSV has 81 columns and the test CSV has 80 columns. That's because the test
The fuck? 80 kolom. Apa aja itu anjir?
Data set has all of the features that you would need, but it does not have the feature that you're trying to predict. So I don't know what the answers are for here. That's what I'm trying to guess. I will take these this test data that doesn't have the target column. I'm going to do the exact same pre-processing as I did before, and then I'm going to make some predictions using the model that I've trained up here to several more rounds than the original submission. And then I am going to make predictions using this test data matrix, and I'm going to save it as a CSV. So what I'm saying here is I want a data frame with 2 columns. One column is called ID, and this has the ID information from the test data. And one column is called sale price, and this has my predictions from the submission prediction. And I know that those are the columns that I need because if I look at the sample submission here, I have the columns ID and sale price. And if I don't have the right column names here, when I go to submit my file, I will get an error. All right, once I have made my predictions, I'm going to write those predictions to a CSV file. So I'm saving a file out that has all of my submission information in it. From here, I need to commit my notebook. So committing runs all of your code top to bottom. From here, I need to commit my notebook. So committing runs all of your code top to bottom, and it creates a stable version that you can refer back to later. So if I'm making multiple submissions, I can go back and I can look at the committed version I used for that specific submission. And it looks like it's complete, so let's open the version. And here, if I scroll down, you can see at the bottom we have output files. So I have one output file, submission CSV, that has the predictions that I saved out in my kernel. And I'm going to submit this file to the competition. And it's submitted, and the submission is complete. And it looks like my score is 0.16. And if I jump to my position on the leaderboard, I might have to wait a second for that to be done. But you can see that I have my score, I've made my submission, and from here, all I need to do is keep trying new things and improving my model and then making new submissions as I think the things that I did will improve my overall model. So that's it. That's all you need to do to enter a Kaggle competition. Obviously, I wrote some of the code off screen, but you're also, of course, welcome to use the kernels that people have made public for various for a specific competition, and also check out the discussion and see what people are talking about that particular competition. All right. Thanks so much for joining me. That's all you need to do to join a Kaggle competition. And now that you know how, I hope I see you on Kaggle. I'll see you then. Hi, I'm Rachel, a data scientist here at Kaggle, and today I put together a video for you to learn a little bit more about Kaggle etiquette. Especially if you're new to the platform, you might be a little bit confused about what some of the expectations are about how you should behave. And if you know a little bit of Kaggle etiquette, you can make friends, contribute to the community, have a good time, and maybe get a few medals. All right, let's go. Hi. So you may be wondering why bother with etiquette at all. So like all communities, whether that's a sports team or a family or a business or a classroom, Kaggle has certain norms and expectations for behavior. And if you don't follow those expectations, folks may be annoyed with you. So knowing what those expectations are on the forums, in kernels, and in competitions means that people are going to be more receptive to your content, more likely to answer your questions, and more likely to give you upvotes. So on the forums, a good general rule of thumb is to contribute in useful information and respect people's time. So part of that is making sure that you're asking your question in the right place. So if I have a question about a specific data set, I probably don't want to ask that in the product feedback forum. I want to ask that in the datasets forum. Or if there's the dataset exists on Kaggle, I can ask it on the comments for that specific dataset. Similarly, if you have questions about a specific competition, ask them in the forum for that competition. That's why it's easier for people to find your question and answer it. And you can also see what other people are saying about the same thing. If you're asking for technical help, which I encourage you to do, there's just a couple things you can do that make it more likely that someone is going to answer your question and also show that you are respecting the time of the people whose help you're asking for. So the first thing you should do is search the forums and see if somebody else has had the same problem. Best case scenario, you find the exact answer to your question. You don't even need to bother asking anybody. You can just use the answer. If you can't do that, when you start writing your question, you want to make sure to have enough information that somebody else can reproduce your problem. So you might hear people talking about reprexes, R-E-P-E-X, so reproducible example. That's what they mean. And on Kaggle, the easiest way to do this, if you're asking a question about a kernel, is make your kernel public and then share a link so that other people can take a look. Also, respecting people's time, show that you've already tried something, that this isn't just the first thing that you're doing is going to the forums and asking questions. You've worked on it on your own, you're really stuck, and you can tell them what you tried that didn't work, and that'll help them narrow down the answers that they might have. Also, be very specific when you're asking your question. So the more specific your question is, the easier it is going to be for somebody to help you. So if you're asking, hey, I want to know more about machine learning, that's a very broad question. It's going to be very hard to answer. But if you're saying, hey, I'm looking for good papers that talk about, I don't know, reinforcement learning for robotics underwater, that's a much more specific question, and people will be more, it'll be easier for people to answer it for you. And also, if you're polite, it's just going to make it more likely that people will want to help out. So again, nothing wrong with asking for help. I encourage you to do it. But showing that you're respecting other people's time makes it much more likely that they're going to help you. So here's a good example. This is a question from the Kaggle forums. This person had a problem with converting some values to date times. And you can see in their question, they say what they tried and what happened. So this is a little reproducible code snippet. The only way I think you could improve this was if this was happening in a kernel, to share a link to the public kernel. And they was also very polite. So they had a little greeting, hi everyone, and they said appreciate any advice. And this question did get answered pretty quickly. So this strategy worked really well for them. Some other general guidelines about posting to the forums: avoid things that are a little bit spammy. So anything where you're advertising a product or really self-promoting. So if someone is asking a question and you have an answer and it's in a kernel you've written, it's great to link the kernel there. That's very helpful. But if you're just like, here's a link to 8 of my kernels, upvote me, I want to be a Kaggle master someday, that's a little bit less helpful for people, especially if they're not on sort of a set of coherent topics or they're kernels that are on very common topics. So I'd probably avoid that. If a message is really helpful for you, give it an upvote to thank the person who wrote the message and also to help encourage them to write more like it. Avoid adding people. So a situation where it might be okay to add somebody would be if you were talking about something in a thread a while ago and then in a different thread there's something that's relevant. You might be like, hey, I don't know, at inversion, this is what we were talking about earlier. Can you help this person? A place where it would be inappropriate to at somebody is like, check out my kernel, at so-and-so, at so-and-so, at so-and-so, at so-and-so, at so-and-so. That's a little bit rude and you might get downvoted if you do it that. Also, try to avoid creating a lot of posts on the same topic and instead consolidate everything into one post. So a good example of this is when competitions start, there's often a bunch of people who are looking for teammates. So it's a little bit more polite to do all of that in a single thread instead of everybody creating their own thread being like, hey, I'm looking for teammates and I'm looking for teammates. In general, just be considerate. Don't be rude to people, especially people who are newer to the platform or newer to machine learning. It's a really rapidly growing field. Just think about how you would want to be treated in this situation and take that into consideration. And just remember, everybody's here to learn and grow. And that includes brand new people, and that includes people who've been here for a really long time who want to learn more, because there's always more to learn. All right, kernels. So sort of similar to forum posts, you want to make sure you contribute useful information, but you also want to give credit where it's due. So in general, if you find a kernel helpful, give it an upvote. It's a little thank you to the author, and it also encourages them to write more helpful kernels. If you have a suggestion or a question, leave it in the comments for that kernel so that they're at the bottom of the kernel. And it can be really motivating for people to get comments like, hey, this was really helpful for me. I was struggling with X, and this really helped me with it. So it's a source of comments that it's just really nice to receive. And you might make a new friend. If you want to expand on a kernel that already exists, so somebody's tried something and you're like, oh, I want to try that same thing, but just sort of change some hyperparameters, for example, make a copy of that kernel. So this is also known as a fork. And you can do that using the copy and edit button. And that creates a copy of their work for you to, play around with on your own. And if you end up making some big additions, then you could make the kernel public and be like, hey, I've made some additions and changes to this kernel, and this is what happened. And you can have a little back and forth with the original author. If you use just a little bit of somebody else's code, so maybe just a function that they wrote, it's considered polite to write above whatever code you're using, leave a little comment and say, hey, this function was written by at inversion, for example, go check out the kernel where he wrote that, and then a pointer towards the original kernel. So again, just considered polite. And just in general, try to avoid creating a lot of very similar public kernels. So whatever you do in your private kernels, that's your business. But if there's, 18 kernels that are created in quick succession on the exact same topic, that can be make it a little bit harder to find relevant things. So sometimes it can be a little bit nicer to find a kernel that already does more or less what you want, and then fork it and edit it for your own needs. All right, competitions. Again, some general guidelines. First of all, be considerate. Follow the rules. That's less of a suggestion and more of a dictate, but also good etiquette. And think about how you can help everybody improve. So during the competition, if you're on a team, make sure you put in your best effort. Your teammates chose you over other potential teammates, so you want to make sure that you're doing your part. Sharing useful kernels is a really great way to get feedback and other ideas for the community. So some types of kernels that are super helpful are really detailed exploratory data analysis kernels, pre-processing pipelines with some helpful functions for people. So those are things that can be really helpful and get a lot of upvotes and maybe some medals on the competition. If there are kernels or forum posts that you find useful, give them an upvote that again says thank you to the author and encourages them to produce other useful content. And of course, read and follow the rules for the specific competition. And this is less of an etiquette thing and more of a hard requirement, but also good etiquette. As the competition starts to get near closing, I would avoid sharing a high-scoring kernel. So you're really high up on the leaderboard, you're doing really good work, you really want to share it with people. I would wait until after the close of the competition. So I'd say probably not within a week of the close of the competition. And the reason is if you have a really good kernel that people could learn a lot from, if it's really near the close of the competition, they're not going to get the time to sit down, understand what you're doing, maybe incorporate some of that into their own work. And also a lot of people will probably fork that kernel and end up having a high score on the leaderboard and having a higher score than people who have been working on the competition for quite a while, and that just feels a little bit discouraging. So that's considered a little bit rude. And of course, as the deadline comes, everyone's getting super stressed. You're training your last minute models. You're like, oh, do I have my submission all formatted correctly? So just make sure that you avoid taking out that stress on other people. And then finally, after the competition, congratulate the winners. You all worked very hard, and it's really exciting to win a Kaggle competition, and it's really nice to get the support of your peers. And if you did score well, it's considered very polite and cool to share your approach so others can learn from it. A lot of people will do that in a forum post, actually. Here's what we tried, and they might even talk about some of the things that they tried that didn't work first, so that can be a really nice opportunity for everybody in the community to learn. And of course, if there are approaches that have been made available, you go poke through them, see what they did, add some things to your own little bag of tricks. And then finally, move on to the next competition. So these have been some etiquette guidelines, and we also do have community guidelines for Kaggle. And there are 4 of these, so be patient, be friendly, discuss ideas, don't make it personal, so no attacking individual people. Threats of any kind are unacceptable, and also any level of harassment is unacceptable. And you can, of course, report it to support@kaggle.com, but we also have a report feature for individual forum posts that you can make use of if it's violating some of our guidelines. And you can find more information on the community guidelines on the forums. All right, so now that you have some more information on what's considered good etiquette on Kaggle, I hope you've got all the tools you need to have a really great time on the site and make some friends and learn something new about data science. And I'll see you on Kaggle. Bye!
Renovasi panggil yang pro. Pencet sekali, gampang bro. Tukang profesional like a Bosch. Dengan produk profesional membuat kerja berat jadi mudah. Dari Bosch.
Hi, this is Rachel, and I'm here to show you the Kaggle's platform. Today I'm just going to give you a quick tour of 3 places, and it is datasets, kernels, and learn. So datasets is our public dataset hosting platform. So these are public datasets that people have chosen to share on the platform. You can see that this top one here is CSV, so it's a comma separated value. There are 2 files for a total size of 9 megabytes. You can see that the license is unknown. This one is under the Open Database license. This one is under Creative Commons 4. It's been viewed 27 times. It has 6 comments, and there have been 33 kernels written on it. You can also see datasets that you've written, and if you upvote a dataset, you can find it under the Favorites tab, along with all of the other datasets that you've upvoted. Kernels is our in-browser coding environment. Again, the landing page for kernels is going to be kernels that other people have written that you can read. You can see that this one has 5 visualizations. It's a notebook, which is a Jupyter notebook with additional structure around it that we provide. It is written in Python, and it has 51 comments. And just as with datasets, you can find your work under this tab, and then favorites are the ones that you've upvoted under this tab. And finally, I want to show you the Learn platform. So this is our data science educational courses. We have some in Python, beginner machine learning curriculum, Pandas, which is a package in Python to allow you to interact with tabular data, like spreadsheets, data visualization. These courses are all in Python. SQL, which is a relational database language, that is written in Python. R, which is a language developed for statistics, and this includes the same content as the machine learning curriculum, but written in R rather than Python. Deep learning, also in Python, and then machine learning for insights. And that's just a quick tour of some of the things that a beginner might find very useful on the Kaggle platform. Hi everyone, this is Rachel from Kaggle, and today I'm going to walk you through using our kernel's notebook environment to do your coding. So when you start a new notebook, this is what you're going to see. You can see that I have started this notebook on a Kaggle dataset. It's this family household with Mary's coupled data from the Census Bureau. And if I want to find out more information on this dataset, I can open the link in a new window. So I'm just going to go around and show you everything and do a little bit of coding to show you some of the potential of the platform. So the first thing you're going to want to do is create a title, and I'm going to call this Family Analysis Test. And this title does have to be unique among all of the titles in your kernel's history. And you can see once I say the title and I click out of it, then the commit button turns blue. So this will allow me to save a static copy of my work that I can refer back to later. My work is being saved as I go along. You can tell by looking at this draft save. If you have some sort of error, like you lose internet connection and it drops the session, you'll see an error message here letting you know that you need to download your notebook and save it locally. And you can do that using this button. This will download your IPython notebook file. Or if you have a file locally you want to upload, you can upload an IPython notebook file here, so Jupyter Notebook. You can also, if you prefer to work in R, we start our kernels by Python in default, but you can also use R. And in Python, we only support Python 3, so if you're using Python 2, you're going to run into some errors. We only support Python 3, so if you're using Python 2, you're going to run into some errors. This is the coding environment if you used a Jupyter notebook before. It's very similar. If I want to add additional cells, I click in an existing cell, and I can click this button to create a cell above the current cell, and this one to create a cell below the current cell. And then, of course, I can delete cells using the little trash can icon. If I want my cell to be a markdown cell, so supporting text rather than code, I can do that, and then I can write some text in here. I can do some bullet points if I like. And then some random text. And then to see this correctly formatted as it would be when I'm done committing it, I can just click outside of that cell and it will render the markdown. Other things, I can run cells by clicking in them and then hitting Control and Enter, or clicking in them and then hitting this little blue button here. If I don't want to see the output, so this is listing all of the files in the input directory, I can hide output using the output button. This will only hide it in the published notebook, which is what we see once we hit commit. When we're working in the editor, it won't hide anything. And we can also choose to hide the code as well, if that's something you're interested in doing. And here I'm actually going to delete everything but pandas. And I'm going to read in a file to work with. So I'm just going to call it, nope, I think that's a reserved word, my data. And I'm going to use the read_csv option from pandas. To get the address of where the file is in the current file system, I can click into one of the files that I've loaded in earlier, and you can see up here there is the file path to this exact file, and I can see a little preview of it as well, and I can also see information on each of the variables. Oop, and I can download it locally if I'm interested, which is what I just did. So I'm going to copy this file path and then paste it in here in quotes because it's a string. And this will be different for every file in your data set, and if you have multiple data sets, they will be in different folders within the input folder. So you might have /input/dataset name /file name. And just to show that it did read in, I'm going to show the head of the data set. You can see that it looks the same as it did in our little file preview. A little quick tour of this area. You have information on your session, so you can see that this has been running for about 5 minutes. I started it just before I started the video. When I commit a version, I will see every version that I've committed here, so I can go back and look at the work that I did previously that I've saved a static version of. And you can also see that right now I have one uncommitted draft, so this is the draft I'm working in now. I can add additional data, I can upload data locally, I can add additional data sets. And I can also add output files, so if I've created a kernel or someone else has a public kernel that has some sort of file saved from it, I can add those files to this notebook. So you can create a nice little pipeline. We also have some other settings, so if I want to make my data set, my kernel public, I can do that, or I can add specific, my data set, my kernel public, I can do that, or I can add specific accounts, so I could add my admin account to this as an editor if I was interested in doing that. I can also change the language here. Docker, when you add custom packages, if you add custom packages, it will create a new Docker version. So that's the computational environment that you ran your work in. And you can refer to previous Docker versions that you've created previously in other kernels and run kernels that you make in the future against that same version. By default, it's going to do the latest available. And that will contain, the libraries and modules that we think are most important for data science. And there's a lot of them. It's a fairly big Docker. You can also enable GPU, I'm not going to do that right now, and you can enable internet access. To install packages, you can either use pip, the Python package manager, or you can install directly from GitHub. If you are a command line person, you can also use the API, and this button will take you to our GitHub repo with all of the documentation, or you can see the documentation for the kernels themselves. If you don't like this little panel, you can collapse it by clicking there, the kernels themselves. If you don't command line person, you can also use internet access. To install packages, you can either use pip, the Python package manager, or you can install directly from GitHub. If you are a command line person, you can also use the API, and this button will take you to our GitHub repo with all of the documentation, or you can see the documentation for the kernels themselves. If you don't like this little panel, you can collapse it by clicking there. And finally, you have the console. So if I just want to do, some basic math or write some vanilla Python, I can run this in the console, and it won't be saved. When I exit this session, the console output will be.
Memang terminal bisa gitu ya. Cepat. What happened with my laptop, bro?
removed. So if you're just sort of like playing around, the console is a good place to do that. And finally, you can also restart your session. So this will clear your environment and give you pretty much a blank slate in which none of your cells have been run. And the final step is to commit this. This is a blank slate in which none of your cells have been run. And the final step is to commit this, and this will bring up a progress window. You can actually click out of here and continue to work because this is being run in a different environment, a new, fresh environment. And then once it's done committing, we can go and look at it, and we will see that our code that we have here at the point when we commit it has been run top to bottom, and that's what I'm looking for. Made to look pretty. So you can see the output, and if we wanted to see this output from the top kernel, which we hid, we can choose to show that. There isn't any right now, but sometimes when you import libraries, you'll see warnings and stuff. And that's all you need to know to get started working in the kernel's editor in Python. Have fun, and I hope you guys find out lots of interesting stuff.
When you imagine the future of art, is it still? Or does it move? Sculptures that
Hi, today I'm going to show you how to upload a dataset to Kaggle. So I'm here on my Kaggle homepage. I've logged in. I'm going to go to Datasets and then create New Dataset. And here it will open a dialog box, and you'll see that I have several different options for uploading a dataset. So if I have a remote file at a URL, I can use the URL. I can import an entire GitHub repository, or I can create a dataset from a kernel, the kernel output file. But today I'm going to do the simple one, and I'm going to call this mock data, and then I have a CSV file that I've downloaded here. So I'm just going to drag and drop that CSV file into my dataset and hit create. If I wanted to upload more files, I could use this upload more files button instead. And it'll take just a little bit to upload your dataset and create the page. And now that I've uploaded my dataset, I can go to dataset and I can create a new notebook and start coding right away using the data that I've uploaded. Dataset and create the page. And now that I've uploaded my dataset, I can go to dataset and I can create a new notebook and start coding right away using the data that I've uploaded. I hope you found this helpful. I have been Rachel Tapman from Kaggle.com, and I will see you on Kaggle. Bye.
Rachel Catman.
Hi, this is Rachel from Kaggle, and today I'm going to show you how to start a kernel and add your own data that you have locally on your computer. Show you how to start a kernel and add your own data that you have locally on your computer. So first I'm going to click on the kernels tab here from the Kaggle homepage, and then I'm going to create a new kernel. And by doing it this way, I'm going to create a kernel that's not associated with the specific data set that we have on Kaggle. It has no data sources, and you can see that that is indicated right here. And I'm actually going to add a data source that I have locally on my computer.
Apa ini? Apa itu? Thank you, Mas Napan.
So when you click add data, you get this option to upload a data set. You can upload a local file, and I'm going to do that. And I'm going to select a file to upload, and in a window that you can't see, I am using my File Explorer to select this mock data CSV. And I'm just going to call this dataset mock data test. It's private, so no one else can see this data set. It's already a CSV, but if it were in a different format like an Excel file, I could convert it to a CSV if I wanted to. And I can now create this. And so this is creating a new data set that I can interact with like any other data set on the Kaggle platform. And it is adding it to my kernel here. So if I, once my kernel reloads, because we're restarting the virtual machine, I can import pandas as PD, and I can import my file as I would any other file. So it's in the one directory up, and then it's in the input directory, and it is called, let's see if we take a look at the mock data file. We can see that it is mockdata.csv. So I can actually just copy and paste that file path in order to get the file that I need. And then I can interact with it like any other data set that I have read in. And this is generated data, this is not real people's data. And that's all you need to do to load in data that you have locally.
Convert your audio and video files into accurate text transcripts in seconds.
Hi, this is Rachel for Kaggle, and today I'm going to show you how to write code on a data set that we've hosted here on the Kaggle platform. So the first thing I'm going to do is find a data set, and I'm interested in Legos. So I'm going to find a Lego data set. And we have some options here, but I'm going to use this Lego database that I uploaded. Once I've come to the dataset page, I can create a new notebook on this dataset by going to this Analyze Data dropdown and starting a notebook kernel. And this is a Jupyter notebook that has some additional nice environment around it that we provide. And this will launch the notebook editor window. So the first thing we can do is we can enter a title for it. My Lego analysis. By default, our kernels start in Python, but if you would prefer for them to be in R, you can choose that from the drop down here. You can also upload an IPython notebook that you have locally, or you can download your notebook to save locally. When you commit your notebook, drop down here. You can also upload an IPython notebook that you have locally, or you can download your notebook to save locally. When you commit your notebook, you run all of the code from top to bottom, and you create a stable version that you can refer back to later. And you can see here, I currently have one uncommitted draft. This means that my work is being saved, so you can see draft saved up here, but I can't come back to this version later if I want to leave. I'll come back and I'll see the current version that I'm working with and not one from a specific time point. You can also see some other information, how much compute I have available. Once I've committed a version, I'll be able to access it here, and every new version I commit, I will also be able to see here. We've started our kernel on a dataset, so I can see information on my dataset here, and you can see that it has a lot of different CSV files in it. Committed that. And I'm actually going to zoom out a little bit so I can find the close button and zoom back in. We also have settings, so if I want to make my dataset public so that anyone can see it, I can change that here. Or I can add a specific user, so if I wanted to add myself and my admin account, I could do that here. And it would send me an email, my admin account an email. I can also change the language here as well as up here. I can change the Docker image, so you can see that I've created a Docker image with custom package installs that I've used in other kernels. I can turn on the GPU or internet. These are currently in beta, so there may be some variation there in how those perform. And I can also install a custom package. In Python, I can install either from pip or from a GitHub repo. If I'm in R, I can only install from a GitHub repo. You can also find more information in the documentation here, and this is opening up in a new kernel, a new tab, and you can find a lot more information on kernels here. And finally, I can interact with kernels and datasets programmatically using the API. If we want to write some code though, I'm going to erase what's in here, and I am going to import pandas as PD. And then let's read in our data file. So I'm going to call my object data, and I'm going to actually write I can see that at the top here there's a little path to where the file is here to get the specific. we'll read it in, and putting my cursor highlighted code when we previewed it over here, the highlighted code. So this is the head of the data that I've read in, and it looks the same as it did when we previewed it over here. And then the final thing I can do is I can commit this, and it will create a stable version that I can come back, click out of here, and continue working in my, my kernel environment. And that's how you get started working in kernels on Kaggle. Have fun.
For anyone with dementia, do not drink warm water. Did you know that memory...
Hi, this is Rachel from Kaggle, and today I'm going to talk about forking kernels. So kernels are in browser coding environment, but you can also use them to share work. And we've got a lot of public kernels, and let's find one to fork. So I'm interested in this Data Science for Good Center for Policing Equity competition, and I look at this notebook that somebody else did. Let's find one to work. And we've got a lot of public kernels are in browser coding environment, but you can also use them to share work. And we've got a lot of public kernels, and let's find one to fork. So I'm interested in this Data Science for Good Center for Policing Equity competition, and I look at this notebook that somebody else has written, and it says extensive EDA. And I look through it and I'm like, oh, this is some cool stuff. I want to extend it further, and I want to start with where this person has started. So I can do that by forking this notebook. So what forking does is it creates a copy of everything that you see here that you can use and play with. So if I click fork, it's going to launch the editor, and I'm going to see in the editor everything that was in the version of the kernel that I forked. And you can see I can run all this code, I can edit it. So let's say I want to, I don't know, have a new variable, data is good, and I'm going to assign it the string, yes it is, and I can run this cell. So this is my copy of the notebook that I can do whatever I want with. And it doesn't affect the original author's notebook. So if you look over here in versions, you can see one uncommitted draft. And if I commit this, I will get a new version that is including my work, but again, it does not affect the notebook that I forked from originally. So forking is a concept from source control or version control, and if you haven't run across it before, it can be a little bit confusing. But when I open the version of my notebook, I can see that it is a fork of a different notebook. My notebook I forked. I will get a new version that is including my work, but again, if I open this cell, so then assign it the string, yes it is, and I can run this cell. So this is my copy of the notebook that I can do whatever I want with. And it doesn't affect the original author's notebook. So if you look over here in versions, you can see one uncommitted draft. And if I commit this, I will get a new version that is including my work, but again, it does not affect the notebook that I forked from originally. So forking is a concept from source control or version control, and if you haven't run across it before, it can be a little bit confusing. When I open the version of my notebook, I can see that it is a fork of a different notebook, and that I have you can see the things that I've added if I go to the version tabs, and you can see from the original fork, I've added 2 lines. And it is that sort of like very silly thing that I did here. And this is my difference. Yeah, so this is a way for you to use other people's work, build off of it. This is private, so no one will see this fork, and you can see because it's private here, they will be able to see the number of forks. So if somebody forked this, once I made it public, I see forks 1 here. Currently, there are no forks of this notebook. But until I make it public, no one will be able to see this work on the original, and it won't change the notebook itself. It'll just show up under the forks tab up here. All right, that's pretty much what I have to say about forking, and I hope you guys can really build off of other people's work and find out some cool stuff. Have fun. Hi, this is Rachel with Kaggle, and today I'm going to show you how to find work that you've done previously. So the quickest way to find work that you've done previously is to go to your bio, your profile, and you can do that by going to this icon that is the one that you've uploaded in the upper right hand corner. And if you haven't uploaded anything, this will be a goose. And then go to my profile. And then when that loads, you can see some information about your account. So you can see your rank in competitions and kernels and discussion. And you will also notice that up here, there are some tabs. So the competitions tab shows you all the competitions you've entered. You can see I haven't entered any competitions in this account. In this one, you can see the kernels that you've written. The most recent kernel you've run is going to be on top in this little yellow box here to help you find it a little bit easier, but they'll all be here. And you can see that there are ones that are uncommitted drafts, there are ones that are private to you, there are ones that are public, and then there are ones that have been shared with you. So this is one that I've shared with myself for my admin account. And you can also see discussions. So if you've been chatting on the forums and you want to go back and find something that you said earlier, you can find it under discussion. And then finally, if you've added data sets, you can see the data sets. And no one will be able to see this tab until you create a public data set. And that's what's in your profile and how to find information and kernels that you've written previously.
I just made a $27 ebook in 2 minutes using AI. Watch how I did it so you can do it too.
Hi, this is Rachel from Kaggle, and today I'm going to show you how to search for datasets on our public datasets platform. So I've gotten to this page by going to the Kaggle homepage, www.kaggle.com, and then clicking on datasets. And today I'm going to be looking for some astronomy datasets. So I don't really care what the size is, but I could filter by that if I were looking for very large or very small data. I don't care what the file type is, I'm okay with any file, but I want to make sure that it is Creative Commons licensed, so I want to know that I can reuse it, and this will include all Creative Commons license flavors. And I also want something that's tagged with astronomy data. So let's just search for astronomy, and that tag will pop up. And this gives us some results. So you can see we've got quite a few astronomy data sets that are licensed under various flavors of CC. This one is Creative Commons 0, so it's in the public domain. And I could use any of these in my project with no restrictions pretty much on how I can do it based on the datasets license. And that's how you find datasets on Kaggle. Hi everybody, this is Rachel with Kaggle, and today I'm going to show you how to upload your own dataset. So to start with, I'm at the datasets listing here. Here on Kaggle, kaggle.com/datasets. You can also go to Kaggle and click on this datasets link up here.
Wow. Bring me to bed. Wake me up.
Here. And if I scroll down, you can see we have a lot of different data sets, many of which are uploaded by users, some of which we actually maintain ourselves to make sure that they're up to date. And if you want to create a new data set, you do that by hitting which we actually maintain ourselves to make sure that they're up to date. And if you want to create a new data set, you do that by hitting the new data set button here, and this will pop up a dialog box. And I have created some mock data for this purposes, so I'm going to call this my fake data. And I'm going to have it be private. You can see I have a quota, so I can only have 20 gigabytes of private data on the site at any time. I can have as much public data as I want. I'm also going to choose to convert tabular files to CSVs. The file that I'm going to upload is already a CSV, but if I have like an Excel file or something else that's sort of a little bit more difficult to read in programmatically, then you might want to convert it to a CSV or a comma separated value. So I am going
Running session. Interaction. Bring me to life. Man. Bring me to life. Let me up inside. Save me from the madness. Oh, nggak pernah sampai berbunyi.
Going to upload my mock data set here. You can see I'm calling it mock data. And I clicked and it brought up a dialog box on my personal computer just to allow me to select it. And you can see it's been uploaded. I could upload additional files if I wanted to. If you want to maintain the file structure, you should upload a zipped file of your directory, and then that will save the nesting. Otherwise, everything will just be uploaded as a flat structure. And now I can hit create. And my upload speed on my personal internet is a little bit flaky right now, so we'll see how this goes. It looks pretty good. Not too bad. So I've created my data set and I hit confirm, but I'm not done. I can start using it now, but if I want to share this data with other people, it's going to be pretty hard for them to understand what's going on. So we've created actually for you a checklist to help you make sure that your data set is high quality and people can follow along with what you're doing. So I'm going to add a subtitle, totally fake, not real data. And you'll see that there's like emails and IP addresses. And again, 100% made up and not real. And it should be a little bit longer. So totally fake data that's made up. Save changes. And now we should add a tag. So you can see we've automatically detected the size of the data set. It's small. I'm going to say it's business and it's also, is fake a tag? It is not. Is data a tag? Yeah, it's definitely tabular data. It's maybe database data. Adding a description. So you can see that we've given.
Oke Google. Nggak bisa kalau pegang aja. Oke Google. Google. Hey Google. Hey Google. Tabular data itu apa?
Data adalah sekumpulan informasi atau fakta mentah yang dapat.
Tabular data itu apa?
Tabular data adalah jenis data yang disusun dalam baris dan kolom. Setiap baris mewakili satu
you a suggested flow for what goes into your description, but this is totally fake data, so I'm just going to leave all of that and write that. Totally fake data. Save that. You can upload an image, and I'm not going to do that right now, but you just choose a banner image to upload. Unsplash.com has lots of public domain data image files that you can use as your image header, and they're very nice. And you can also describe all of the files. And if you've forgotten what's in your files, we give you, and anyone who comes in and looks at your data set once it's public, a really nice little sneak preview. This is not all of the rows that are in my data set, but I can look at all of my columns. You can also sort by column. In the little preview screen. And we've also got this option that tells you the name of each column and then the data type that we've inferred. So this file contains totally fake data. Again, I just want to make real clear, this is not anybody's individual data. And we also have an option to add information on each of the columns. So I'm not going to in this case because I think the column names are fairly straightforward, but I think it is important to know that this is probably the primary key. So this is going to be unique for each person. And I'm going to save these changes. And then they want us to include all the column descriptors, and I didn't, but you can go through and take time to make your data look really nice so that other people can use it and find a lot of value in it. And if you suggest questions, maybe people will spend some time doing analysis on your data. Another thing that you can do on a data set that you've uploaded, if you're not entirely sure what's interesting about it or you're just getting started, is you can start a starter kernel. So this is a kernel that does some very basic exploratory data analysis. So we have created it here, and if we looked at Edit Notebook, we could check it out. And it's automatically being committed, which means that the code is going to be run from top to bottom. And until it's run all the way through, we're not going to see the output. So let's go back to our data set. But then once it's being run, we'll see some nice exploratory data analysis that might help you kick off your analysis. And that's all there is to uploading data to Kaggle. A little bit more advanced stuff. We've added insights recently, so you can see everything that happens when you upload a new version of your data, and it'll save the version and information on each of the versions that you've uploaded, but you can see a little bit more information here. There's also a discussion forum on every single data set, so if you're interested in having a little chit-chat, you can do that with the public if you make it public, or with specific people that you've added to it. So I can add other users to my data set, even though it's private, so they'll be able to see it. So I might add, for example, my admin account, and I might give myself viewing privileges, or I might say that I can edit it. You can also make it public here. Again, uploading the image. We've been here before when you're going through the checklist. And you can also specify the license. So by default, we just say unknown because we don't know until you specify it, but we have a lot of different licenses supported, and of course you can upload a license with your data set. And then the default is versioned, and I recommend that you do that, but if it's a very large data set and you only want the latest version, that is an option for you as well. And of course, here's where you can delete it. And that's all you need to get started. I hope you guys do a lot of interesting data analysis and see fit to share some of your cool data. Have fun.
Bring me to life. Wake me up inside. Bring.
Hi, are you a researcher looking for a place to share your data? Today, I'm going to walk you through how to do that using Kaggle datasets and highlight some additional features that we recently added specifically to help researchers like yourself, maybe. So let me walk you. Hi, are you a researcher looking for a place to share your data? Today, I'm going to walk you through how to do that using Kaggle datasets and highlight some additional features that we recently added specifically to help researchers like yourself, maybe. So let me walk you through the process. To start with, I'm going to create a new dataset. I'm going to call this my research data, and I'm going to upload a file from my computer. And once I have uploaded all of the files that I want to add, I can create a new data set. You can also as the search data, and it is private. So let's imagine that I am submitting some papers, or maybe to a conference or maybe to a journal, and I want to include some links to my data sets, but I don't want to make them publicly available yet. So in order to do that, I can come here under sharing and turn on link sharing, and this will create a link that anyone can use to view and download the data set without me having to make it public to everyone. And there's also some additional things I can do to make my data set.
Anyone with the link can view and download the dataset.
Without me having to make it public to everyone.
Oh.
And there's also some additional things I can do to make my data set more useful. So you have a little list here. So I could add a subtitle. I'm going to call this helpful. CC0 public. I'm going to add a license, and I'm going to say CC0 public domain. So very permissive license. Again, this is randomly generated data. I'm going to say that it's versioned. So every time I update the data set, people will be able to refer back to previous versions of the data set, and will also be able to see what changes I made. So this can be helpful if you are working on some sort of data that you're going to want to update over time. Let me save that. From here, I can add a banner image. I'm not going to add text, so I add tags to help people find new data. I can also, once I'm ready to share my data set, make it public. So I'm going to permanently make this public. Anyone can use it. Anyone can find it on Kaggle, and you can see the private icon goes away. Once your data set is public, you can actually create a digital object identifier, or DOI, for your data set. So first, I'm going to need to save some information. I'm going to add an author. So Rachel Tapman, that's me. Bio, I am a Kaggle. I'm going to add for DOI. For your data set. So first I'm going to need to save some information. I'm going to add an author. So Rachel Tapman, that's me. Bio, I am a Kaggle data scientist. If this is part of a co-authored paper, I can add additional authors here. I'm also going to say sources, randomly generated data. No collection methodology, that's not relevant for me. I don't have any other collaborators who have worked with me on this data set, but I could add additional Kaggle accounts, so they would also be able to edit the data set. Update frequency, I'm never going to update this randomly generated data. Time start, there's no sort of time coverage, but I could add that if I wanted. Spatial coverage, if I were working with geographic data, I could say this is for Africa, this is for Asia, this is for the state of Washington, or whatever specific spatial area you are looking at, and then save changes. And once I have updated that information, I can generate a digital object identifier that will uniquely identify my data set and can be used in citations. So those are some of the things that we have added specifically for researchers. Something else you might find helpful is tasks. So we've added this pretty recently, and this will let you create specific things that you would like someone to do using your data. So maybe you're looking for a cleaned version of the data set. Maybe you have a text field that's very has a lot of variation in it, and you would like someone to go through and, let's say, find all the keywords from that text field. You could create a task here to do that, and then ask people to submit either data files or kernels or notebooks or code, so to accomplish whatever specific task you are looking at. So those are some features that we have added that should be particularly useful to researchers who are interested in sharing their data on Kaggle. I hope you find this useful, and hopefully I'll see your data on Kaggle at some point in the future. Thanks for joining.
Okay, y'all, today's the day. I've built my model, I've studied my data, I've made my pancakes, and today we're gonna do it. We're gonna submit these pancakes and their recipe to the International Pancake Competition. Wish me luck. Okay, y'all, today's the day. I've built my model, I've studied my data, I've made my pancakes, and today we're gonna do it. We're gonna submit these pancakes and their recipe to the International Pancake Competition. Wish me luck.
Listen, the suspense is getting to me as well, but before we find out how my machine learning pancakes did at the International Pancake Competition, I want to let you know that this video corresponds with the random forest lesson on Kaggle's Intro to Machine Learning. I used my decision tree model to come up with what I thought was going to be an incredibly highly rated recipe. I mean, I wouldn't have been surprised if I got a 9 or 9.5, and a 10 wasn't out of the question, but the judges gave me a 7.5. And a 7.5 isn't bad, but I really thought that my recipe would do better. So what happened? Well, when we work with decision trees, we've considered all of our features and built a relatively good model that lets us look at the value in a leaf and then trace our path backwards to figure out which components of a pancake recipe we should include and in which amounts. And that's great. That's highly interpretable, but it's not necessarily highly accurate. If we want to increase the prediction accuracy of our model, we can use something called a random forest. Now, instead of taking all of our features and combining them into one tree, a random forest is going to do thousands of trees, if not thousands upon thousands of trees, and it's going to randomly select which features or variables it's going to pull into a given tree. And then it's going to take take all of these trees that it's done with all of its random variable selection, and it's going to average it out together in order to give us our final model. Now, this is going to give us generally a much higher prediction accuracy, but it's become a little bit more difficult to interpret. We can't just look at the leaf on the bottom of our tree, trace our way backwards, and figure out everything that has gone into building that model. And that's okay. In machine learning, there's often a trade-off between prediction accuracy and model interpretability, and that's something you're going to learn a lot more about as you continue in your machine learning journey. So just as a forest is made up of many individual trees, a random forest model is one that's built up of many individual decision trees whose features are selected at random. Let's take a minute and review what the basic pieces of code are for us to kind of build our model. So we define a model. That's where we say, hey, I want to use this model. We fit our model, which is where we train our model on a training data set. Then we make predictions using our validation data, and then we want to validate our model. And in this lesson series, we're validating our model using the mean absolute error. So take a second to think about this. We've created a decision tree model using decision tree regressor. What might be different between the code for a decision tree and the code for a random forest model? Let's take a look. Now, what we decide to call our model is up to us. Here we've called it a forest model. So yes, technically that's a change, but really the meat of the change comes in the model that we've defined. And here, instead of decision tree regressor, we've got random forest regressor. So we've defined our model, we fit our model, made our predictions, and now we're ready to validate our model using the mean absolute error. Let's compare the mean absolute error for our random forest to the mean absolute error for our decision tree. And when we do that, we see that the random forest gets a lower mean absolute error compared to the decision tree. So we've already improved our model by moving from a decision tree to a random forest model.
Between everything we've covered in this video, as well as the material on the Kaggle Learn Intro to Machine Learning Random Forest module, we've got two main points I'd like to make sure we recap. One is that the random forest model uses many trees and makes a prediction by averaging the predictions of each of the component or individual trees. And two, the random forest model generally has much better predictive accuracy than a single decision tree, and it works well with default parameters.
We've majorly leveled up our machine learning skills. We've gone from building a model using a decision tree to building a model using random forests. And there's a lot we can do with random forests, but for now, let's make sure that we complete the coding exercise in the random forest module as part of the Intro to Machine Learning series on Kaggle Learn. It'll be great practice to apply what we've just learned. And when you've completed the coding exercise, meet me in the next video where we're going to learn about machine learning competitions. Machine learning competitions are a really fun part of the Kaggle platform, and I can't wait to show you how to get started.
See you. See you. Hey, 5 months ago? What the fuck? Emang iya? 5 bulan yang lalu itu bulan apa? Ding, 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 ding. Python coder, code worker, bookmarker. What the fuck? Is that badges? Ding, 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 ding. Ranked aku mana ranked aku? Ding, 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 ding. Ding, 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 ding. How? You must verify your phone. How? Nggak kebaca kartunya. Hai, Cuki Lasso, Cuki Lasso. The fuck's happening? Lu kenapa lah SIM card aku nih, Cok? Ya Allah. Hmm. 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 Dun, 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 dun. Bro, oh, udah. Anjing. Ulang lah. Allahumma lakasumtu. Kagak kekirim, kocak. Kenapa nggak kekirim ya kode? Cuki Lasso. Masa main-main kau ya? Gue lagi puasa. Gak ada, Cok. Eh, mana? Sumpah nggak ada anjir. Astagfirullahaladzim. Ar-Rahman, alam Al-Quran. Khalaqal insan. Alamul bayan. Tolonglah. Nggak mau sih. Oh, gerak. Yes, I didn't receive a call. Kok bisa nggak kehubung? Ar-Rahman, alam Al-Quran. Khalaqal insan. Alam Al-Quran. Wah, ini last try nih. Kalau misalnya nggak bisa, aku datangi kantor Kegel. 08 atau nggak pakai kosong. Coba. 08 08. Jangan bikin aku buka sekarang. Kirim anjir. You only one have Kaggle account. If you have another account, you need to first delete the account. The phone numbers needs to be yours and not public or shared numbers. Contact us for help. Bapak dia 24 hours. Saya ya coba kirim SMS ke nomor Rajin ya. Kirim SMS ke nomor Rajin. SMS. Rajin nggak tahu kartu Jin nggak tahu baca tahu ah nggak tahu Jin gue. Asal aja, yang penting ada pesan. Tuh. Oke, Lea tak kirim ya. Lala, thank you. Wah, Lea tak kirim. Lea. Masuk. Ya, makasih. Salam. Ar-Rahman. Al-Qur'an. Khalaqal insan Udahlah anjing, udah. Shit, you know shit, you fucking shit. Okay, and where's the rank? What is this? Your group invites, groups you manage. Okay, how about the settings? Okay, on verify. Damn, like damn, drop down. Oh, so I use dark damn. Bagusan mana? Okay, go. Nanti create token, routers, private data, private models, 200 gigabytes. What is GPU and TPU? Your LinkedIn account allows you to access Google and Google Cloud and GitHub services in notebooks. Okay, so how about this? Aloneness and tips email. Updates from Kaggle likes new competitions, course, and features. Of course, I need that. Alert about your work. Mana kok nggak ada ranked ya? Pesan kemarin ada ranked. What is this? Login streak. Today's new record. You're all jump back in or start saying something. And it's my public activity and it doesn't show anything. And so, coba kita buat si dana ya. Wow. Bio. Following badges. Competitions. And following. Okay. Okay. Data scientist at university. Student. Cause baby, you're the one satisfies me. You're my like say if you're living with me. Gimana sih? There is something I would never. The chair is not visible on your public profile until you have public activity. Oh gitu. Aku karena belum punya public activity. Shop. Okay, let's go home. The public activity here is the progress to Kaggle progression system. Kaggle progression system uses performance tries to track your growth as a data scientist on Kaggle. Along the way, you'll earn medals for your achievement and count for data science learning. Categories of expertise. The progression system is designed around our Kaggle categories, competitions, notebook, dataset, and discussions. Advancements through performance tiers is done independently within each category of expertise. Performance tiers. Within each category of expertise, there are 5 performance tiers that can be achieved in accordance with the quality and quantity of work you produce. Novice, contributor, expert, master, and grandmaster. And right now, I'm a novice user. The heck? Pemula. Beginner. For example, you could be competition master, dataset expert, a notebook grandmaster, and a discussion expert. Expert. Okay, home. Awesome data science at Kaggle, San Francisco, joined 2 years ago, lesson in past day. Competition master. Okay, so he is a master of competitions, expert at datasets, grandmaster at notebooks, and expert X discussions. There's 1 medal, 1 gold medal, 3 silver medal, and 2 bronze medals. And I think, okay, the highest star you have achieved in any categories of experts will be displayed on your profile and under your avatar across the site. Tires are awarded on the basis of medal earned in each category. Okay, well, contributor. You have completed your profile. Engage with the community and fully export Kaggle's platform. Expert. Gimana cara saya menjadi contributor dalam makanya? Dan gimana saya menjadi expert? You've completed significant with a form Kaggle in 1 or more categories of expertise. Once you have reached the expert tier for a category, you will be entered into the site-wide Kaggle ranking for that category. 2 bronze, 3 bronze, 5 bronze, and what? 50? Medals are standardized way of recognizing and awarding some species of works across the categories of experts. Each medal awarded for a single accomplishment, agreed competition results, a popular notebook, a useful dataset, or an insightful comment. Competitions medals. Competitions medals are awarded for top competitions results. The number of medals awarded for competitions varies depending on the size of the competitions. Percentage calculations are rounded down. For example, a competitions with 9 teams will not award any gold medals. Note that community playground and getting started competitions typically do not award medals. Okay. Datasets medals, notebooks medals are awarded to popular public dataset. Not all outputs count towards medals. Self-votes and votes by novice are excluded. Okay. And how about the competitions one? Oh, based on the result. Kaggle ranking points, Kaggle rankings. And here there's competitions. I don't know what is this. Why there's a formulas here. The Kaggle rankings page is a live leaderboard of the absolute best data science on Kaggle. Wow, so ini kayak top global gitu. Each category of expert. How to rate this? Expertise, expertise. Expertise, expertise.
Expertise.
Expertise. Okay, so artinya apa tadi? Expertise ya, expertise. Keahlian. Each category or expertise has its own leaderboard and point system. Data scientists probably display the rank, as well as the highest rank they have ever achieved for each category. A data scientist must be expert tier or higher to be ranked for that category points. While tiers or medals are primary representations of data science achievements, points are designed to decay over time. This keeps Kaggle's ranking contemporary and competitive. All points awarded decay inconsistent using the formula. In this formula, T is number of days elapsed since the point was awarded. Whoa. Okay, what page is this? This is the page of Kaggle Progression System. Oke, itu tadi pas aku ngepencet apa ya? Ini kan. So basically, aku baru 25%. Run one notebook or script. I need to make one completion submissions and make one comment and give one upvote. Okay, I'll do it later. And dataset, what's that mean? Notebooks. I have two notebooks. Notebooks, total to created, competitions, one total joined, course, total completed. How to start? Choose a focus for today. Help us make relevant suggestions for learned, content and Kaggle. Take short course, browse inspiring data science code. So basically, there's course here, but jangan dulu dah. Kaggle notebooks are dioper ke sini. And this is by tax and okay, this is the trending one. There's tabler, summit field, learn course, shit, economics, SK learn, competitions, notebooks. Okay, what else? And here we're explore data sets, steps, jumps back in. New from Kegler's you follow Kegler's posted dataset 3 days ago. Okay, so basically it's dashboard and this is home page. New from Kegler's you follow Kegler competition. Okay, so basically this is the competitions. And here we have learn to compete on Kaggle. Okay, comes our grades according to grow. Just 1% in terms of data science knowledge are you? I think I'm a beginner. Titanic. I think it's the same thing like this one, right? Or it is a different thing? It's the same thing. So this is for the beginner. If it's 1607 tim. Alright. So basically it's the same thing. So I'm gonna submit here. Ini beda atau sama sih? It's basically the same thing. Shit. What did I do? So it keeps increasing. Okay. So this is for beginner competitions. There's Titanic. Housing prices competition for casual learning users. And adventure regression techniques. So, okay, I'm gonna try that one. And then I can try with intermediate. 2 days to go. Browse all fragrance competitions. And in advanced, I have this ones. AI Mathematical Olympiad for best prize too. Whoa! $2,000. Damn. Browse all competitions. Also competitions your work. So there's a lot of competitions here. AI features with prizes. Getting started approach. What is this? So there's getting started competitions. So there's some categories of competitions. Okay, so what we have here, there's a research community, and there is a playground, fun practices, problems, simulations, ship. And there's simulations and there's analysis. And this is a feeder competitions, I think. Wow, there's a lot of feeder competitions here. Hoping juga masih lama. And here we have 30% community spotlight. Recently ended, and there's a lot of getting started competitions, but maybe I will start with this more community competitions. Okay, maybe I'm gonna see this all. So okay, so there's a lot of getting started competitions. What we have here, there's a LLM classifications fine tune. Ada space with Titanic. Store sales, time series forecastings. What is this? Natural language preprocessing with disaster tweets and house prices. Back of words. First step with Julia. Special key points. The science London as scalar. Just the basics. Titanic machine learning from disaster. And there are a lot of okay. Oke, aku udah terbayang apa yang bakal aku lakuin selanjutnya. Okay, so basically here we have what is this? This is a code. Okay. Ya. Okay, so the first step thing that I need to do is to complete and make submissions from these competitions. It's called Titanic Machine Learning. Okay, I'm gonna close this all. Oke, sebelum itu aku mau istirahat dulu. Udah 2 jam ya kita ngulik kayak gitu dan ya udah itu doang sih. Gue dapat gambaran dikit. Setidaknya ada dapat gambaran dikit. Kita bakal lanjut sebentar lagi. Aku bakal beristirahat terlebih dahulu. Ya, I'm back. Sabarnya udah buka tuh belum? 17.47 udah. Nah, sambil nunggu nasi masak, kita bakal mencoba memahami lombanya ya. Okay, so here aku udah baca ini. But in this conversation, we'll gain access to two similar datasets. Two similar datasets that include passengers' information like name, age, gender, socioeconomic class, etc. One dataset is titled train, and the other one is test. Trains will contain the details of a subset of passengers on board. To be exact, okay, ada 891 penumpang. And importantly, will reveal whether they survive or not, also known as the ground truth. The TCSV dataset contains similar information but does not okay, but does not contains similar information but does not disclose the ground truth for each passenger. It's your job to predict these outcomes. Using the patterns you find in the TransSV data, predict whether the other 400 on board found in test. This is feature 5. Check out the data tab to explore as even further. Once you feel you've created a competitive model, submit it to Kaggle to see where your model stands. Our leaderboard schemes or Kaggles. Does not disclose the tidak menggunakan outputs to predict these outcomes. How to submit your predictions to Kaggle? So first click on submit predictions buttons and upload a CSV file in the submissions file format. Okay, you're able to submit 10 submissions a day. So, situ tuh kita submit predictions. Submissions file format, you should submit a CSV file with exactly 4x and triple with as a hero. Your submissions will show an error if you have extra columns beyond the passenger ID and supply. Selain passenger ID and supply rows. The file should have exactly 2 columns, passenger ID sorts in any order, and sub 5. Content here banner represents 1 for sub 5 and 0 for disease. Disease ini berarti artinya nggak semua. Disease, almarhum. Okay, disease. Get it. I'm ready to get started. Where do I get help if I need it? For competence help, Titanic discusses forum. So we have forum here. How do I open the forum? Titanic discussions. Oh, here. Okay. Right. Kaggle doesn't have a dedicated team to help troubleshoot your code, so you'll typically find that you receive response more quickly by asking your questions in appropriate forum. The forums are full of useful information of on the data, metrics, and different approaches. We encourage you to use the forums often. If you share your knowledge, you will find that others will share a lot in turn. The last word on Kaggle notebooks. As mentioned before, Kaggle's notebook is our known setup customizable Jupyter notebooks environment with free GPUs and huge repository of communities published data and code. In every competition, you'll find many notebooks shared with incredible insights. It's an invaluable resource worth becoming familiar with. Check out this competition's notebook here. So we have code. I think it's tab for tab code. Bukan ya. Titanic and we have notebook. Titanic server versions using scalar. Decision tree. Okay, there's a lot of notebook here. What the difference is, there's a peanut notebook. How about code? I think it's the same thing, I guess. Notebook, right? Okay. So, and then here we have, okay, ready to compete, join the competition here. Overview. Okay, so, evidence. It is your goal job to predict if passengers survive the sinking of the Titanic or not. For each in the data set, you must predict 0 or 1 value for the variable metric. Your score is the percentage of passengers you correctly predict. This is known as accuracy. Submissions file format. You should submit a CSV file with exactly 408 418 entries plus a header row. Your submissions will show an error if you have extra columns. Passenger IDs and providings. Okay, so this is the example. You can download an example submissions file, get your submissions CSV on the page. For now, what is getting started commissions? Getting started commissions were created by Kaggle data scientists for people who have little to no machine learning backgrounds. They are a great place to begin if you are new to data science or just finished a MOOC and want to get involved in Kaggle. What is MOOC? Secondary Massive Open Online Course, yaitu kursus daring berskala besar yang terbuka untuk siapa saja. Okay. Getting started competition are non-competitive competitive way to get familiar with are a non-competitive way to get familiar with Kaggle's platform. Learn basic machine learning concepts and start are a non-competitive way to get familiar with Kaggle's platform. Learn basic machine learning concepts and start meeting people in the community. They have no cash prize and are on a rolling timeline. How do I create a managed team? When you accept the competition rules, a team will be created by you. You can invite others to your team, except merge with another team and update basic information like team name by going to the more. team page. We have heard from many Kagglers that teaming up is the best way to learn new skills and have fun. If you don't have a teammate already, consider asking if anyone wants to team up in the discussions board. What are notebooks? Kaggle's notebook is a cloud compositional environment that enables reproducible and collaborative analysis. Notebooks support scripts in Python and R, Jupyter notebooks, and markup notebooks. You can visit the notebooks tabs to view all of the published cert code for the tiny compositions for more on how to use notebooks. Learn since take out our courses. What is this? Kaggle, your courses patterns. There's a lot of courses here. Okay. Why did my team disappear from the leaderboard? To keep with the spirit of getting started comes we have implemented a 2-month rolling window on submissions. Once a submission is more than 2 months old, it will be invalidated and no longer counts towards the leaderboard. If your team has no submissions in the previous 2 months, the team will also drop from the leaderboard. This will keep the leaderboard a manageable size, present it up, and prevent newcomers from getting lost in the sea of abandoned scores. Okay. I worked so hard to get that score. Give it back. Read more about our decisions to implementing our. How do I contact support? Okay, and there's a key essence here. Okay, I'll go. And how about the data? Okay, data descriptions. So there are 3 files, and that is a CSV files. Subjects, counts, and rules. The data has been split into 2 groups: the training and the test. Okay, the training sets will be used to build your machine learning models. For the training sets, we provide the outcome, also known as the ground truth. For each passenger, your model will be based on features like passengers, genders, and classes. Your model will be based on features like passengers, genders, and class. You can also use feature engineering to create new features. The test sets will be used to see how well your model performs on unseen data. For the test set, we don't provide the ground truth for each passengers. It is your job to predict those outcomes. For each passengers in data test set, use the model, but you're trying to predict whether lah. Oh.
Jin,
Ah,
ayah tuh ulang tahun gini atau 31?
hari kok.
La ilaha illallah.
Udah lupa.
Kok cili story yang tadinya ulang tahun sibuk nah orang hari karayu itu harus kepatan tinggal menariknya. Banyak orang. Ajin lah kecek.
Lah.
Oh ya udahlah. Makanya udah tanya. Cili story Umi saya tadi kan.
Ya.
Ada orang ya ada betul.
Okay. We also wait. We don't provide it is your job to predict these outcomes for each passenger in the data set. Use the model to try to predict whether or not they survive the sinking of the Titanic. We also include gender submissions, CSV, a set of predictions. Gender submissions, set of predictions that assume all and only female passengers survive. As an example of what submissions files look like. We also include gender submissions, a set of predictions that assume all and only female passengers survive. Detection and survival. 0 and 1. P class, ticket class, the first, second, and third. Sex, and there's an age, and there's a siblings, spouses aboard the Titanic. Spouses itu pasangan, jadi siblings itu saudara anjing. Sibling itu saudara anjing. Saudara, masa iya. Saudara dibilang nggak berjaga. Kok nggak usah ngeremehin aku juga ya, Jin. And there's a spouses, pasangan, and there's parts of parents and children aboard the Titanic, and the ticket number, fare, passenger fare. I don't know what is fare. Tarif penumpang. Okay, and cabin, and the embark part of embarkations. There's a 3 port, the Cherbourg, Queenstown, and South Mapsong. Farewell notes. P class, a proxy for socioeconomic status classes. Upper, middle, lower. H is fractionals if less than 1. If the H is estimated, is it in the form of XX5. The datasets defines family relations in this way. Siblings, brother, sister, stepbrother, stepsister. Bentar. Okay. The age is fractional if less than 1. If the age is estimated, is it in the form of xx.5. The data sets defines family relations in this way. Siblings, brothers, sisters, stepbrothers, stepsisters, spouse, husband, and wife. First, the data sets defines family relations in this way. Parent, mother, father. Child, daughter, son, stepdaughter, stepson. Some children traveled only with a nanny, therefore price golongan for the product. Gender submissions that CSV. Okay. An example of what a submission file should look like. This person assume only female strangers certified. Okay, so ini contoh submission. What is compact? Oh, ini detail. And this is compact, and this is for the color. And then what we have here, download data. What is this? What is this? Kaggle API. Oh, I can download data kalau misalnya kayak gini kan cara download data di Kaggle. Metadata. Okay, and how about the code? There's a lot of code here. Titanic tutorial. Single from disaster. Titanic with TensorFlow Decisions Forest. Di sini dia ada yang pakai Decision Forest. Terus di sini ada juga yang pakai scalar. Decision tree, random forest, binary classifications. Banyak yang pakai decision tree random forest ya. Tapi aku kayak bakal nyoba pakai logistic regression basic dulu sih. Kira-kira bakal semana gitu. Okay. And the model here. There's a lot Titanic random forest. Ada pakai lelama. Ada yang pakai YOLO. The fuck? The discussions here. This contest has an official Discord channel. Whoa. Getting started competitions. First comment. Matching the names variable using auto variables. Looking for feedback, and there's a leader over here. Oh, jadi di sini nama tim. Whoa. Okay, and this is, what is this? This is a score. Do you mean this is the perfect score, or what the fuck is this score? 1 day, 2 months. Yeah, okay. And rules. Rules exception is not required for this mission, but like comes in rules once accounts for participants. The private term mergers, team limits, submission limits, constant standby, county specific term. Okay, so basically I can start, but there's a lot of discussions here. I want to penasaran. This Compton has an original Discord channel. Okay. Great work, guys. It's a great competence. Competent to be contributor. Nice, bro. It's very helpful. Thank you. Excited about learning more on Kaggle. It's good competence. It was really helpful. From anyone since we're using Kaggle. Was given a test on Kaggle to was comment something and I don't know what to say. So how do I pro the informations? Okay, so basically this is the forum. A lot of forum here, and how about this? Coming back to machine learning after 9 years of there's so much really useful for beginners. I would like to learn more on machine learning, and I'm very excited about it. I agree with you. And what here? There's first comment here. Yeah, I understand. And oh, what the fuck did I press? What the fuck, bro? Yeah. Okay, we have a lot of topics here, and the timer was using LLMS. Ada yang pakai LLMS? Pakai apa dia? Hello everyone, I want to play around with LLMS, specifically Gemini and Python Gamma. Okay, dia pakai Gemini. The main motivation was to convert this structure problem to a text confidence problem as well as knowledge already with enough predictions. So I run a bounce and a half back I tried making predictions using Gemini and several fine-tuned variants of Gamma to 2B. I was able to achieve a score of 0.7 with fine-tunes, which was better than my experience with Gemini 2.0 plus. I've shared the code and I'm keen to learn from the other who have learned in this context. Okay, jadi dia pakai Gemini. Is it possible to predict the age using variable using the other purpose? So there's ada no values ya, ada nilai yang dan itu adalah age. I find that a lot of dealing with missing age variable is just use the main. I find a lot of dealing with I find that a lot of dealing with missing age variable is just use the main. I tried using random forest to create predictions of other variables for the age variables and had 50 mean MSA itu apa ya? MSA itu mean standard error. Mean standard error. Kayaknya mean standard error. Oh, mean square. Oh iya, kok standar sih mean square error. The mean square error. I'm sorry. Untuk mengukur seberapa baik modal sudah itu mengenal. Bagaimana cara menginterpretasikan angkanya? and had 50 MSA and 0,76 R kuadrat. R kuadrat ini apa ya? Aku pernah catat R kuadrat, tapi aku lupa itu apa. Let me check it. Let me check it. R square. R square is SSR bagi SST. And the R squares, no. Is this practice appropriate? The best score was at 0,78 and what can I do more to improve this? If you could share a bit of evidence on interpreting missing data, it will be much appreciated. Have a good day. H as a numerical column can be imputed using small technique. Learn its wording. That technique may be slow, but it's very good for filling any numerical missing data. Thanks for it. It seems like small technique I understand deals the problems of unbalanced labels in a dataset. Will you be willing to talk in more detail about how it works in dealing with missing issues? Oke, transfer. Oke, telah orangnya sebenarnya saya pahami dapat mengatasi masalah label yang tidak seimbang dalam hubungan data. I use the sklearn's input class in my Python code for inputting missing values. Specifically, I use the KNN imputer. They are a good example on the sklearn. 2 days ago and 7 days ago. And how about this? 9 days ago. Okay, maybe I can start this. Now it's this never melted. I worked it down to this. Cause they said that means I realized coming. It's not for everything.
Have you ever thought about maybe entering a Kaggle competition, but you didn't really know where to start, or you felt a little nervous, so you went to... site, and there's so many things, and it was very overwhelming. Don't worry, I've got you covered. Have you ever thought about maybe entering a Kaggle competition, but you didn't really know where to start, or you felt a little nervous, so you went to the site, and there's so many things, and it was very overwhelming. Don't worry, I've got you covered. Today I'm going to talk about how to get started in a machine learning competition on Kaggle, specifically the Titanic machine learning competition, which we've designed to be the best possible starting place for you. So today I'm going to talk about why to do machine learning competitions, also how, but mostly why, what this specific competition is about, what should you do first, so you've entered, what next, what happens, and then the thing that everybody wants to know, how can you improve your score once you started, climbing up the leaderboard, how can you keep going up it? So why should you compete in this competition? In general, machine learning competitions are a really nice way to play with different techniques and methods where all of the hard and kind of boring work about data science has already been done for you. So the data has been clean, somebody's developed the metric, there's a really clear problem, there's a nice description of everything that's in the data so you don't have to figure that out yourself. And you can just try different methods and see what works. It's also a really nice way to familiarize yourself with Kaggle and the platform and everything that's on Kaggle. So of course we have competitions, but in the course of the competition you might want to use some different data sets and you might look through Kaggle's data sets. You can actually write and run your code directly on Kaggle using Kaggle notebooks and then submit from one of your notebooks. We have a video on how to do that. And even if you never do another Kaggle competition as long as you live, it's a really nice way to also start interacting with the community, make some friends. Everybody in the forums is just starting out. We've designed this to be specifically for new Kagglers. So it's a really nice place to ask some questions, maybe answer some questions, and become a part of the Kaggle community. And just so you know, in case you, again, really aren't interested in competitions, the leaderboard is actually cleared every 3 months, so if you're playing around, you don't get a great score, that's fine. It'll disappear. No harm, no foul. All right. Let's dive into the challenge. So the Titanic was a passenger ship that very famously and tragically sunk on its maiden voyage, and the majority of people who were on board the boat died. So the thing that we want you to figure out is how to build a model to help predict what factors might have led to somebody surviving or not. So we'll give you information on each of the passengers. For some of them, we will tell you whether or not they perished in the sinking or not, so that you can use that information to train your model. And then for some of the other passengers, we won't. And your job is to try and guess for those passengers that we haven't told you about whether they survived or not. So how do you start? The first thing you need to do is accept the rules and join the competition. From there, you need to get the data. So the data is going to be under the data tab on the competition page, which is the same place you went to join the competition in the first place. And it's going to be broken into 2 files. One is the training data that I mentioned that has all of the different information and features and also information on whether or not the passenger died. So you're going to use that for your training and your evaluation and your cross-validation. And then the second data set doesn't have any labels, and that's the data set that you're going to send your predictions back for, and that's what you'll be not really graded on, but evaluated on to determine your leaderboard position. Once you have the data, the next step is to really understand the problem, spend some time learning about the Titanic. It's really well documented. And maybe you take a movie break and watch the movie Titanic just to refresh your memory about what the situation of the problem is. And then do some exploratory data analysis. Are there missing values? Are there skewed fields? How are you going to deal with these things? So really get to know and understand the data set. And then start your modeling. So training models, tuning them, changing the hyperparameters to try and get better results for your models, and then ensembling the models, taking your models and putting them together to get your first predictions, and then upload those predictions and you'll get a score. You're on the leaderboard. You're already starting on your journey. And our recommendation is to start with Alexis's step-by-step tutorial. So Alexis is fantastic. She's an amazing teacher. And this tutorial will help you walk through step-by-step, answering your questions, and help you get started in a really nice, simple way. And then the question that everybody wants to know, okay, so I've made my first submission. I want to see those accuracy scores improving. What do I do? A couple of things you can try. So the first And then the question that everybody wants to know, okay, so I've made my first submission. I want to see those accuracy scores improving. What do I do? A couple of things you can try. So the first thing is to learn about the data. I said that you need to understand the problem. There's always more to learn about a specific machine learning problem. For the Titanic in particular, of course it happened in the past. There's no new data being produced around it. So you can turn to historical sources and start to learn more about the situation to develop your understanding. And then you can use that understanding to guide your experimentation. So some things you can do are creating new features, so feature engineering based on what you know about the data. Try different types of pre-processing. So maybe if you tried one method of filling in missing values or imputing them, maybe you try a different method and see if that changes your results. Different types of machine learning models. So you might try a random forest-based model. You might try a support vector machine. You might try a regression model. You might try many different types of models and then combine them, ensemble them is the technical term. And these are very, very popular on Kaggle. Probably the majority of Kaggle competitions are won by some sort of ensemble model that has multiple different models combined together. And then finally, and this is probably actually the most effective way to improve your score, learn from other folks who are doing the same competition. You're all just starting out, you're getting your bearings. People will share lots of helpful code, they'll ask and answer questions in the forums, and you can help build your understanding as part of the community and really, become a full-fledged Kaggler, get your Kaggle badges, I guess. You don't really have badges. And start climbing up the rankings. All right, you've got everything you need to do and know to get started on the Kaggle competition. I'm really excited to have you on the site. Welcome, and I look forward to seeing you on Kaggle. Good luck. Bye.
Analysis. Alright guys, so here is my Kaggle profile. As you can see, it is really new. I haven't unlocked any achievements yet, but hopefully that will change in the near future. So let's jump into the actual notebook here so we can find the competition here in the Titanic. It should be one of the ones at the bottom here. It's only up here because I've participated in it. So before I enter in any competition, before I go through any workbook, I make sure to understand actually what's going on, like where the data is coming from, who it's going to be valuable for, and everything along those lines. So we can go through and read here, and then these data. So you can see what the test data looks like. But what is really relevant here for me is the data. So if you click on the data tab, you can see how to actually submit. You can see what the test data looks like, what the columns, it looks like there are 11 columns. And you can also get some information about the individual variables. So for example, like siblings might be useful, number of parents on board. These are all very relevant things. So I always want to make sure before I do any feature engineering, before I start experimenting with the data, I have at least a little understanding of what the data encompasses. Next, let's actually work into my notebook. So if I wanted to create a new one, I would click here. I'm not going to go through this live because some of the training takes quite a bit of time, and also maybe I'm a little nervous to do it live yet. So I'm going to go through one of the workbooks that I went through, but I'll still talk about some of the places I get stuck, some of the challenges that I had, and again, I really hope that this is helpful to you guys. So I think this is it. So here we always talk about how to write about your work. I mean, this isn't a perfect case study, but the way that I use Markdown, the way that I use comments is hopefully very clear to you guys. Right now, as you can see, I talk about
Emang tiketnya bisa bukannya harusnya unik ya? 70x% snow. Oke, aku bisa nyoba sendiri sih.
About what I plan to do with the data. I talk about what my best results were with the analysis
Anjir, best resultnya 79%. Dan itu top 12%.
that I used, and I walk through each of the steps that actually eventually got me to submitting my results. So we'll go into this a little bit, but one thing, I actually write the overview at the end. I go through, I do all my outlining, and then I go back and make sure it makes sense to me logically how I go about it. So in this one, they actually just give it to you. You import the data. I think at the top you also have to include the data. And we read it in with this scripting. So before I do any project, I just like to think about the problem in light of the actual data that we have. So this is a thing, some comments that I do before I run almost every analysis. I go through these steps. So the first thing, I want to understand the data. So like what data types are they? Are we working with numerics? Are we working with categoricals? What are some of the trends of the data? What are the averages? How many missing values do we have? Next, I look at the histograms and the box plots. This helps you understand the trends in the data. So we might see that, for example, for fair, there's a lot of people that didn't pay anything. Is that something we have to dive into further? The following thing is I want to understand the value counts for the categoricals. So you can't really do histograms for categorical variables. So value counts, it just gives you like a nice little bar chart to see what categories people fall into. After that, I explore missing data a little bit more, and I start thinking about how I'd want to either remove missing data or impute the missing data. Following that, we want to start thinking about our model building, and we do some correlation between the different metrics. We see what things are related and which things are related to our dependent variables, especially in a regression problem. This is clearly a classification problem, though. We're trying to predict a yes or a no. Yes, they survived. No, they didn't. Going forward, I just kind of brainstorm a couple things that I want to understand better. So, did wealthy people survive? Did the cabin that they were in affect their survival rate? Did age affect their ticket price? Is young and wealthy maybe a variable we want to explore? And then do we want to explore total spend? I actually don't think I went through and analyzed these yet. So in a follow-up, maybe I'll go through and see if those actually affect the model that we have. After that, I wanted to do some feature engineering. I go through and maybe make some new variables. And then after that, we pre-process the data so that we can use it in the analysis in our models. After that, we start doing the model building. We think about, do we want to scale our data? Is it relevant? And I'll talk about some of the assumptions there. Now, there are really two things in my mind that affect how your model performs. The first, and which I think is probably the most important, is the data that goes in. So the better data that you have, the better your model is going to perform. The other ways you can actually tune your model and mess around with parameters, but I found that usually you get the biggest jumps when you include better data. And so that's where feature engineering is really important. I think that's probably the best way to make a couple percent increase in your performance, even over model optimization. So let's jump right into the light data exploration here. So what I like to do is I just run a couple of quick little commands to help us understand the shape of the data and these types of things. So as I've mentioned before, we do training, which is our training data set, which we've isolated here. And we want to understand the data types and also the null values. So we can see age has quite a few null values and cabin has quite a few null values. So we're going to want to start thinking early about how we're going to manage them. We're going to go through and actually look at the differences down here, but this is just a good starting point. The next thing we want to do is I always want to try and use the describe command, and so this shows us like the standard deviation, what percent of the sample survived, the average age of the groups, the average family size, and things like that. So these all start helping us think about the data differently. We start just making associations, and we're not reserving judgment yet. We're just starting and continuing to think of questions as we go. When we do this, I think it's relevant to break this into numeric variables and categorical variables. So these are things that we want to understand with a histogram, and these are things that we want to understand with value counts. So this line of code here, I just make histograms for all of the numeric variables, and I just plot what they are up top. So age follows a fairly normal distribution. Like the siblings do not, and neither does like the parents. The fair also does not follow a normal distribution. So these are, fair, for example, might be something that we want to actually normalize, because there's such a spike at a very low price. Some of these other things, there's few enough categories that it probably wouldn't matter, and age is already fairly normally distributed. So we don't really have to think about
Oke, Google. Google. Saya kan lagi mencoba project data science, dan di sini kayaknya klasifikasi, dan di dataset ini terdapat banyak fitur kan. Nah, di fitur-fitur ini kan ada fitur numerik ya. Nah, apakah semua fitur numerik itu?
Oke, saya mengerti. Jadi, kamu lagi ngerjain proyek data science tentang klasifikasi dan punya banyak fitur di dataset kamu ya. Nah, karena fiturnya banyak, beberapa di antaranya mungkin fitur numerik. Benar begitu?
Ya, itu benar. Nah, jadi di sini saya ingin bertanya, apakah semua fitur numerik itu harus dalam bentuk distribusi normal? Karena di sini contohnya age atau umur ya. Nah, itu tuh udah dalam bentuk normal. udah dalam bentuk distribusi normal. Nah, apakah fitur-fitur numerik lainnya itu juga harus dalam bentuk distribusi normal? Saya nggak paham nih, kenapa kita harus mengubahnya menjadi distribusi normal, atau itu sebenarnya nggak perlu?
Fitur numerik perlu diubah jadi distribusi normal kalau model machine learning yang kamu pakai mengasumsikan datanya berdistribusi normal. Misalnya, model linear regression atau linear discriminant analysis. Tapi, ada juga model yang nggak masalah dengan distribusi data yang nggak normal. Contohnya, decision trees atau random forest.
Kalau kan ini klasifikasi ya. Kalau klasifikasi kan bukan regression linear. Kalau misalnya saya pakai logistic regression, itu berarti semua fitur numeriknya harus dalam bentuk distribusi normal.
Nah itu dia, logistic regression itu kan buat klasifikasi, bukan regresi linear. Jadi, asumsi distribusi normal nggak berlaku di sini. Logistic regression lebih fleksibel, karena bisa menangani berbagai jenis distribusi data.
Oh, oke. Berarti saya nggak perlu membuat fitur-fitur numerik yang lain ini untuk berubah ke dalam distribusi normal.
Benar sekali, nggak semua fitur numerik harus berdistribusi normal. Apalagi kalau kamu pakai model klasifikasi seperti logistic regression. Model ini cukup fleksibel kok, jadi kamu bisa langsung coba latih modelnya tanpa mengubah distribusi datanya.
Normalizing it. So I might have said scaling. We'd want to normalize these and then scale them. So let's now look at some correlations. So as we can see, the number of parents and the number of siblings, so like families tend to travel together. These are, so age and the number of children is very highly has a very negative correlation, and these help us to just understand the different relationships in our data. If we're using regression, this could be really, really important because we want to avoid multicollinearity, and that's when there are two variables that are too highly correlated and they have a overwhelming effect on the model. So the next thing we do is we just want to look at how survival rates differ across these different groups. So if they survive, what's the average age of survivors? What's the average price that they paid? The average family size and the number of children. So, it looks like, these are not statistically significant, but we can start to see that, okay, younger people might have a higher chance of surviving, people that paid more, maybe the rich survive, which is a kind of sad story here. If you have parents, so if you're a kid and your parents are on board, they might put you first. And if you have siblings, if you're a child, you might have slightly less of a chance of surviving. So these are all things that we want to take note of and think about when we're building our models. The next thing we do is we do a very similar thing to the histograms here, but we use our categorical variable data. So we look and see, okay, what is the survival rate? So 0 is not survived, 1 is survived. How many people are in each class? So there's less people in these two. These are probably general tickets. These are probably first class. Actually, we should look and see what those things are. So let's go back to the data. So we can see class. So yeah, first is first class, second class, third class. Now we go down and we look at, these are kind of unintelligible, but we can see, roughly the distribution of how much people paid in classes and on cabins. And then we can see where people embarked from. So we can see that embarked, Cherbourg, Queenstown, and Southampton, those are the 3 locations. And we can evaluate how much of an impact all of these things have. So after we've done that, we do something very similar to this pivot table, and we do it for each of these different things. And we want to compare it to our dependent variable, which is if people survived. So we can see that by class, a lot more people in first class survive proportionally than in these other ones. This probably suggests to us that there's some value in understanding this actual problem. This will probably be relevant in our model. The next thing is, men and women. So it looks like the saying, women and children first, actually applied in this scenario. here. Finally, we don't really see anything too relevant. Maybe if they got on dislocation, they have a slightly higher chance of surviving. All right, now moving on to the feature engineering. So we saw that ticket and cabin, there's just a ton of data, and there's only, I think, 800 or so samples here in the training set. So if we have too many columns, that really doesn't cooperate well with our data. So we want to simplify some of this through some feature engineering. So if we look at the actual cabin data, we see that there's basically a letter and then a number following it, and that's what cabin it is. So I wanted to separate them into individual cabins. And to do that, I used a little bit of regex. So we just split here on spaces. And in the first one, I just wanted to see if they had multiple cabins. So some people had multiple cabins. It looks like the vast majority did not. And we can see here that, what the survival rate looked like across those things. The next thing is I wanted to look at the actual letter of the cabin that they were in. So you would expect that cabins with the same letter are in roughly the same locations. They might be the same floor, whatever that might be. And again, I used some very simple, like a regular expression to strip this out. So N stands for NA. If you recall that we had, almost 3/4 of the data was null for this variable, but we can actually treat that null value as a categorical. So maybe if they don't have data on it and we mark that, it might tell us something different about the data there, or it might tell us something additional. So we don't just have to drop those rows and not use them. We can use them as a feature, and maybe that can help us. It probably won't, but it's at least worth experimenting with. So as you can see, a lot of the people in the null column did not survive. People that actually did have a clear cabin had a lot higher survival rate unless they were an A. So I think that we can comfortably use the column letter as a categorical variable here, and that might give us a little bit more insight. It takes it from having 50, 100 different unique cabins to having like less than 10 or so. The next thing we want to look at is the tickets. So each ticket number was fairly close. It was either unique or very close to unique, but some had letters and some just had numbers, and I thought that might be telling. It probably is related to where they embarked from and things like that, but it was worth experimenting with, so I included those here. Just as a variable, if they have a number, if they have a number, then it'd be a 1. If there is some text involved, then it would be a 0. So as you can see, I just kind of explore all of the different ticket lettering conventions, and I didn't think that any of these were common enough that we'd actually want to include them. So I just removed that and kept this more simple variable. I probably could have aggregated, I think CA or any of these with A's in them could have been combined together, but I didn't really know what all of these things were for, and maybe if I wanted to go further in the analysis, this is something that I would look at. So the next thing I wanted to do is see if this had any impact. It looks like these ratios are pretty similar, so there wasn't really any value added from that, but it's again worth experimenting. I think something that I want to make very clear is that when you're doing this, it is experimental. A lot of the things that you try are not going to work, but that makes it so much more exciting when one of the things that you do try does work. So we experimented with the ticket letters here, and again, there wasn't anything too relevant. In some of the models that we're going to use, it makes sense just to throw in as much data as you can, and the model will sift through it. In the random forest or decision trees, they split on the greatest variables that have the largest differences first. So if there's nothing really significant there, it probably wouldn't split on it at all, or at least very late. So the next thing we do is I wanted to look at the individual people's names. So I thought that this might give us a little bit more data than just if they were male or female. So as you see, there's doctors on boards, reverends, majors, there's a lady, a countess, and these are things that might, if someone's royalty or something like that, they might have a higher chance of surviving. For a lot of these, they're very small samples of, so I would have liked to have aggregated just slightly more, but I thought, for the sake of time and for this data set, I would keep it as is. There aren't too many different surnames. Again, I did this with some very simple, regular expressions or just by using some basic Python commands. If I wanted to really try and improve this, I'd try and group some of these names together. Maybe working people like doctors, reverends, or military people should be grouped together. And it'd also be interesting to see if the captain went down with the ship or not. I think that's like an idiom that people talk about quite a bit. So after we've explored the data, and again, this isn't very in-depth of an analysis. This is just enough to get moving on the model building part. I probably could have spent 20 hours just on the data exploration part, and that's kind of what makes a project unique, is that you can go down these different avenues. You start thinking about these different questions, like like this one that we just talked about, if the captain survived, or if royalty had a higher instance of surviving. You can really make some cool visuals relating to that as well. I didn't want to focus this one as much on the exploration. I just wanted to go through kind of a whole pipeline to get you guys familiar with the process here. So next we go into actually pre-processing for the model.
Oh, I'm back, guys. So there's a lot of things happen between us, but I don't know what's really going on. What is this? Kalau di homepage bisa kasih kalian secara real time, kira-kira bisa direalisasikan? Kayak di atas, tuh kan? Coba aja sih. Oh, so shit, between us. So fucking dizzy and siapa ini? Hyper AI. Wow, who are you? Wow, menanggapi. Maksudnya menanggapi itu apa? Just between us. I'm sick. Just between us. I can't sense it. Wow. Javier, who are you, Javier? So basically, maybe after I end this YouTube video, so I'll try it by myself this night or tomorrow. Terus besok lebaran. Aduh, lebaran aku harus ke tempat saudara-saudara. Maksudnya, what should I do? How to run? Kalau pakai solusi persaingan online, tak bisa sih. Harus ke cara lain biar bisa dapatkan. Mungkin kita bisa dikasih peluang ini for the whole product. Terus bisa bisa di
So none of these models handle null data well. So we want to drop the null values from embarked through kind of a whole pipeline to get you guys familiar with the process here. So next we go into actually pre-processing for the model. So none of these models handle null data well. So we want to drop the null values from embarked. We also only want to include relevant, you guys familiar with the process here. So next we go into actually pre-processing for the model. So none of these models handle null data well. So we want to drop the null values from embarked. We also only want to include relevant data. So I only included ones that we had featured engineered or that were like fine as they were.
P class 6H SIP support fair works cabin Adobe. What is this? Cabin multiple numeric ticket and name title. Okay.
Next, we have to actually, transform all this data, and I used, pandas get dummies. What that means is when you have multiple.
But this approach, we can ensure that our training and data set have the same columns. We also may be able to infer something about the shape of this data through this method. I will stress this is generally not recommended outside of a competition. Use one hard encoder.
Categorical variables. So let's say, like the class, the cabin, right? We have 7 different things. I think it was 7. Maybe it was 10 different cabins. But in order for the model to use that, for each of those individual cabins, you need one column, and the column has a, basically a 0 if they weren't in that cabin, and a 1 if they were in that cabin. So that's how we actually integrate that categorical variable into those categorical variables into our analysis. You can't just have them as one chunk in most cases, or one column in most cases.
Right.
So, basically what I do here is I take all of the data. So I join the training and the test sets because it's easier to make sure that the training data has the same columns as the test data if I do it this way. It also, for the case of a Kaggle competition, might give us a little bit more information in the training set about the distribution of the test set. This is not, I want to be clear, not a good practice for real world data science. You generally want to train a one-hot encoder, you want to train a scalar only on the training data, and then you transform your test data using the encoder that was only trained on the trained data. That assures that your distributions and stuff are very similar. Again, in this case where we want as much information about the test set as possible, it might make sense to do it how I did it here. It's also a lot shorter and easier to do it how I did it here, so for the sake of time, that's why I analyzed it this way. So, going forward, we just do all of the same transforms that we did only on the test set before, and we do them across the training and the test data. We also fill the age with the mean, and we fill the
he filled the age with the mean. All the age fill the training age with mean.
There with the mean as well. We, in theory, probably should have used the median for fair because it was not normally distributed. So that is something that I'll take into account, and I might, when I go back through this, experiment and see if that actually helps. I don't think that there were that many missing fair values. I'd have to look up top. We can do that pretty quickly. This notebook wasn't as short as I thought. So we can see fair. Actually, I don't think there were any missing values. So that's good to know. All right. Next, we actually drop the columns that had embarked. I mean, the rows that had embarked in we drop the rows that had
bukan pas di scan kan pas di scan itu nanti ke list makanan apa aja. Nah, setiap makanan itu dikasih default atau prediksi kasaran berapa beratnya dalam gram dalam kilogram. Nah, itu tuh bisa disesuaikan. Suara aku aneh. No distraction. Fuck you, Paul.
Add nulls and embarked here. Finally, I decided to try and normalize a couple different things. I didn't actually use the normalized siblings in here, it just looked really wonky, but we normalized the fair and we get a closer to normal distribution here, which I think is good. So that to me made sense to use instead of the traditional fair data. So after that, we create our dummies down here, we split it back into our train and test sets, and then we're actually ready to get going here. So we have our train, our train variables and our train dependent variables, and what we want to do is we actually want to try a bunch of these different models and experiment with how they do. So the way that we tell how they do is we use cross-validation. So what that does is it takes some of the samples of our training set and it splits them off, and it trains on this data. So what it does is it randomly samples from our training data. We run a model on some of that training data, and then it predicts on that model with how they do. So the way dependent variables, and what we want to do is we actually want to try a bunch of these different models and experiment with how they do. So the way that we
Before going further, I like to see how various difference model perform with default parameters. I tried the following model using SPY for solutions to get baseline. With the failure since set baseline, you can see how much tuning improves each of those. Just because the model has a high baseline on this person set doesn't mean Success model has high baseline on this person does mean that it will actually do better on even low test set. Knife base 72, logistics 82, decision 377, skinniest 80.
tell how they do is we use cross-validation. So what that does is it takes some of the samples of our training set and it splits them off, and it trains on this data. So what it does is it randomly samples from our training data. We run a model on some of that training data, and then it predicts on that model there. This way, we're validating it on data that's held out, and that should give us a better estimation of how this will perform in the real world. So for the first pass, I just ran a bunch of the basic models without tuning any parameters to see how things would go. So I tried a naive Bayes, which I think is generally the baseline. It's a very simple model. And
Di sini malah ribut sih kan.
you'd expect other models to do better, but sometimes you just want to try with kind of the easiest thing. Next, I looked at logistic regression, decision tree, k-nearest neighbor, random forest, support vector classifier. XGBoost, and then I tried a voting classifier. So I wouldn't really worry about knowing what all of these models are right now. I think it's important to just understand how to implement them. And when you're just starting out in data science, it's okay to just try all the models and see what works best. It gets a little bit more intricate when you're trying to figure out what data you're using and how that goes with the model specifically. Luckily, this data is very generalizable, and pretty much all of these models should work fairly well. You do have to understand a little bit more of the math when you start getting to feature tuning, but that's also an experimental process as well. So we import the cross-validation, and that's how we're going to evaluate the success of these models with the cross-val score here. So to run any of these, you just import it from sklearn. You create an instance of it, and then you can fit it to the data down here. I'll show you how to do this without cross-validation when we're actually predicting for the results on the test set, but I'll save that till a little later. I'm going to go through and show you how I did some feature tuning as well. So the next thing, I think it's important to talk about the voting classifier as well. So a voting classifier means you just take a bunch of the different classifiers and they literally vote on which if they think the person survived or not. So let's say we have 5 classifiers and 3 of them say that they survived. In what's known as a hard voting classifier, then the model would spit out that they believe that that person survived. If we're using a soft voting classifier, that means that the models are sending forward their confidence or the probability that they think this person survived. So let's say let's just use a 2 voting classifier that is soft. Let's say the logistic regression said that it was 100% chance that this person survived, and the k-nearest neighbor said that there was a 30% chance that this person survived. Even though that they're, one is saying one direction, one saying the other direction, you would average the 100% and the 30%. So that would be over 50%, and it would still say that the voting classifier would believe that they survived. So that's how voting works. Generally, if you have some breadth of models, voting classifiers work very well because they help to normalize your results and generalize the data a little bit. So in most cases, ensemble approaches, which are already, random forest, XGBoost are already ensemble approaches. They're really powerful techniques for solving problems. And they are generally a best practice when you're not using deep learning. In this notebook, I chose not to use deep learning. The size of the data is very small, so it probably wouldn't be optimal. And it's also fun to just go through and not have to worry about the deep learning implications going forward. So for the voting classifier, we also did the cross-val score, and you can see it's a little lower than I think the support vector classifier was. And that's okay. Just because these are doing great in validation doesn't mean they aren't, they're going to do as well on the actual test set. So that's something to keep in mind. You still have to experiment with the testing data, and when they're doing really well here, it might actually mean that they're overtraining slightly. So let's go down here and actually start thinking about model tuning. So as you can see, I have a grid or a table of the
performance. The fuck is tune performance?
performance after tuning, and you can see almost all of our
performance after tuning. Whoa.
Our performance increased. For naive bays, it doesn't, really make a ton of sense to feature tune that. There aren't really too many levers you can pull to improve it. With decision tree, there are. But we're using Random Forest and XGBoost, which are both tree-based models, and we would expect that these would actually perform better, so I didn't think it was relevant to actually spend the time tuning that one. What we're going to use to tune is grid search and randomized search. So with any of these, grid search allows you to just put in a bunch of parameters and try them all, and it'll spit out what parameters have the best results. So that's what we do here is we actually go through, we try all these parameters, and these are the parameters that ended up having the best performance for us. And this is the score that it had. So we do that for all of these different classifiers. Each of the different classifiers have different parameters. I think that that's probably a story for another time, but I believe I was fairly exhaustive with most of these classifiers for the different things that you can try. So for Random Forest and XGBoost, there's technically infinite number of parameters that you can try, and if I tried them all, it would take days, months, years, whatever it would be. So I used a kind of funnel approach to find parameters that work well for me. So I did a very broad randomized classifier, so a randomized search. And what that does is it doesn't try everything in this grid. It doesn't try all of the options. It randomly samples from it, and it gives you what the best results were. And then after you have the best results, you can tune it a little bit more and find something that
Bukan kalau pakai pihak ketiga itu maksudnya dapat satuannya berapa, misalnya satu ayam berapa kilogram gitu, misalnya ya gimana sih? Eh, Kalau misalnya pakai pihak ketiga itu maksudnya yang misalnya nih, satu ayam tuh beratnya berapa gitu. Sebenarnya nggak perlu sih kalau misalnya kayak gitu, soalnya di Gemini juga udah bisa kan. Nah, kalau misalnya tanya Mas Nafan pun bukan itu masalahnya. Pertanyaannya adalah bagus nggak kita nerapin yang itu. Soalnya kan masalahnya bagus dan nggak bagusnya. Kalau misalnya kita nerapin, itu kan estimasi perkiraan kan, nggak angka pasti. Misalnya nih, dari foto yang kita kirim ke Gemini, kira-kira ayam yang dipoto itu berapa beratnya. Nah itu kan Gemini jawab, dan jawabnya pun perkiraan angka kasar kan, dan nggak pasti benar, pasti ada beberapa error sedikit maupun agak jauh beratnya dari yang aslinya. Nah pertanyaannya, mending dimasukin atau enggak?
does just a little bit better. So this is a way to kind of simplify on time and maybe shorten your workflow a little bit. So for here, we get our best classifier with random forest was at 83.5%, and then for down here XGBoost, the best performance I believe was like 85.2, which is really high. So in this case, it actually ended up overfitting, spoiler alert, and that didn't produce the best results, but it's interesting to have in here that was a really high performance. One thing that I haven't talked at all about in this is the actual feature importances. So what this means is which of the variables that we put in, which of the features actually have the greatest impact on predicting if someone will survive or not. So, just looking at this, we see that how much they paid, their age, if they're, if they were male basically, if they were female, and then if they were in, I guess it's like normal class, not first class or second class. Those are the things that had the largest impact. Next, we see, like if they had children, and if they had multiple cabins, which is interesting. So I think that all of these are pretty cool and relevant, and that helps us understand our problem a little bit better. So maybe even with our fare, if we experimented with that a little bit more, we might be able to get even better returns. Some of where they embarked from didn't seem that important, and maybe we could actually remove some of these things and they might be a little bit confounding. So for some of our models, for other models, they probably aren't relevant at all. So I went through and tuned these things, and I thought the performance of XGBoost as well as Random Forest were worth exploring and just sending them in. And so I submitted both of those, but I also wanted to do another voting classifier with our actual tuned model. So what I did is I went through and we did the exact same thing that we did before. I just took the best estimators from all of the tuned variables and I made a bunch of different voting classifiers. So I tried a hard voting, a soft voting with just k-nearest neighbors, random forest, and support vector classifier. And then I tried one with all of them except XGBoost. And then I tried one with XGBoost to see how they would perform. And so we can see that, in that order that I did them in, the best results came from this one. When I actually submitted it, that was not the case. The best results came from this one, which I thought was very interesting. It looks like maybe the XGBoost one just overtrained a little bit. And so that's part of this process. It's iterative, it's experimenting, and there are a couple things that I probably want to tweak and see if they actually have a positive impact on. So one of the last things that I did was I wanted to see if the weighting impacted the output here. So I did a grid search and I experimented with different votes in the soft voting classifier. So what that means is I can add additional weighting to one or two of the models so that it counts for more in the analysis. So I tried different weighting all the way across, and it turns out that the weighting that we had was actually optimal. It produced the best score still. So this code is just basically like going through and like fitting all of the data. So for each of the classifiers we made, we have to fit it to the data, and after we fit it, we can go down here and predict the results that we got. So, you know, this is how you'd actually use the models. What this produces is a series with all of the answers to your problems there. So, with all your predictions for the input variables there. So this next one, I just go through and I make them into data frames, and I make it so that I can actually export them into Excel. I ran a little bit more code here to just see what the differences between the outputs were. You know, if we were submitting data that was all the same, you know, if two of the voting classifiers produced the same results on the testing, it wouldn't make sense to include them. So all of them had slight differences, you know, between 3 and in this case, you know, 8 to 12 different variables here. The last thing I did was I actually submitted this workbook, and you do that by just creating Excel files in the local instance, and then at the top, when you go in and run this, you can click up here, and then you can actually commit the changes. So you click that and run it, and it runs through your whole workbook. This takes, for this analysis, because I had all the tuning with random forests, quite a bit of time. So I didn't include those, you know, so I didn't include that part in here. When you actually want to submit, you can click output and you'll have all of your output files here. So let's say I wanted to submit a new version of the XGBoost. I would go through and submit that. And well, it looks like it didn't train, so that wasn't very good. But you get the idea here. So as you can see, the best results that I had were these two runs that I did. I'm gonna probably try and get it just a little bit better so I can break into that top 10%. You know, that's just some fun tuning that I'm gonna experiment with, and you know, hopefully we can do a little better and improve our performance here. So hopefully that was a good way. I mean, this was fairly in depth. This was a long analysis, but hopefully I broke it down in simplest enough terms to get you started. You can go through, you can walk through the code, you can definitely ask questions of me, but I just wanted to get this kind of Kaggle series started. I'm planning to do something along these lines almost every month. I think that showing you how to do some of these projects can really help kickstart things and get you thinking about this in the right way. So as usual, thank you so much for watching, and good luck on your data science journey.
Oke guys, I think udah dulu hari ini. Aku nggak tahu nanti nih bakal lanjut belajar atau enggak, tapi habisnya aku mau mandi. Habis mandi gak tahu aku mau belajar atau enggak. Tapi kepala aku udah pusing. Oke, jadi kita akhiri dulu. Oke.